So in that Google Doc, I think you have to right click on it. It doesn't like right click on it and say open link, or maybe if you click on it, you can just click on the link below it. It should bring up something that might look like this, or it might look like a desktop. I don't know if Dragonfly is going to be launched or not. See the desktop? Okay, so let's go to the desktop actually, and I'll show you what you need to do.
Everyone, if you need to boot up Dragonfly, you're probably gonna get a lot of really little prompts about Dragonfly Social and like registering something. Most all those don't matter.
They're very important.
Yes.
I'll just check. All right, so let me figure out what I'm doing here. Let me minimize this. All right, so basically what you have, if you open up a Explorer window, I don't know the best way to, is in, there's this drive ORSD. In there, there's a folder called Matt Swulius Workshop. And inside of that, there should be a zip file called NYSBC Dragonfly data.zip. Does anyone not see that? And if you need me to repeat things, just say it. I don't have like a tutorial to put up on the screen. All right, so if you just click on that zip, you should be able to hit extract up here, or go to the extract tab and just hit extract all. It's like a 3 gigabyte thing, so it takes like 20 seconds to extract, maybe. Is that working for people? Inside of that folder, there's another folder called NY. It's like multiple folders. Just go inside of those folders until you find macros, models, tomos, and training data. Now, well, actually, you don't need to do anything with it just yet. I wanted to just make sure we had it unzipped, so when we start Dragonfly, we can actually access those files. Let me know if you haven't gotten it unzipped. Okay. Well, there should be a Dragonfly 3D icon on the desktop for you, or there's something already running. I had it tell me earlier that it can't run more than one instance at a time. Let me see if I maximize. Okay. Sorry. Maximizing my screen gives me these icons down here in the taskbar. And so there is a version of 3D, Dragonfly 3D already running on mine. If there is one on yours, then you want to access that, because the license won't allow multiple instances to be running on the same computer. So, all right. Now, has anyone used Dragonfly before? Okay. That's mostly a no. And so I was just trying to figure out where I should start. I have, let's just talk for a minute about the actual workspace itself. Does everyone have this up? So on the left side, there's this sort of main window. There's one called main and one called segment. And this left side has all of the tools and other things that you're really going to need when you're working in Dragonfly. Now, you'll notice that it's kind of a complicated GUI. But you can click on all these little things. They're like accordion kind of drop downs. And so within these are going to be all of these. You can also close them all. Most of them you don't need to have open. And so if you just click on them, you can sort of tidy up your workspace, but that's not terribly important. In the middle, you have these 4 quad views. They're all just showing different axes of your data. And let's just open some data first. So to import an MRC. So most of this thing we're going to have like, well, let's just start with the import. To import an MRC, you want to go to File, and then there's an Import Files selection. It's going to open this window for you, and you're going to press the Add button, and then it's just going to open up a Explorer window. If you can navigate your way to that folder that we just unzipped, it should be on ORSD in here. And if you can get to these 4 folders, there's one called Tomos. And in there, there's MRCs and ORS objects. We're going to talk about ORS objects. They're like the proprietary file format that Dragonfly uses. And they are convenient for importing and exporting things. But I wanted to show you how to get from a raw tomogram into the software. So if you click on MRCs, there's a tomogram called leadingedge.mrc. Let's open that one. Now it's going to give you, this is sort of a, go ahead.
Sorry, my folder is empty.
Your folder's empty. You have one called MRC, but it's empty.
Actually, maybe I'm holding on.
You go to the folder itself here.
Really? Yes.
That's what it's doing.
Too much time.
Yeah, so that, don't, you're not that.
Got stuck with my.
Add.
On the.
Add.
Well,
The folder requires.
Okay.
There's a standard folder.
Yes.
So if you've already figured it out, you can just hit the next button down at the bottom right. And it's going to ask you things. You can ignore most of this. And the only thing I would check occasionally is like whether your pixel size actually makes sense when you're importing your data. Go ahead.
I cannot see the next.
Okay, I was having this trouble earlier. It might be off the bottom of your screen. So go to settings. If you can't see the bottom of the window, you might have to change the resolution of your screen. Try the 1440 by 9. You can't scroll down. Interesting. Yeah, I don't know why. Sorry about that. You might have to change the resolution to get it all inside of the box. So we're literally just going to hit finish though, and we're going to import this tomogram. Now,
Is there a way to turn the lights off in the front half of the room just to make it easier to see the?
Right behind you. The left one.
I don't know, can I turn that on?
The other one on behind.
Is that any better?
Yeah.
All right.
That's better.
All right, so these quads right here, they're showing you different views. This is X, Y, this is Y, Z, and X, Z, I can't remember exactly. But the top one in the top left is a 3D view. I honestly think it's the most useful one. If you double click on it, it should expand and fill your screen. And if you double click on it again, it'll go back to the quad view. And you can look at any of these views that way. But what we're going to do is take into the 3D view. And if you right click or if you right click on the image, you can pick which view you're looking at it from. So just hit X, Y, and it'll go back to the X, Y. The reason why it's useful is if you're in the 3D mode, like you can't look at things in 3D unless you're in that 3D window. But being in it lets you switch between all of the modes. I'm going to try to teach you all of the pro tips that I've learned. I've been doing this for a couple of years. So leading edge, normally you can just scroll up and down with your wheel or your scroll bar to like move through the tomogram. But for some reason on this remote server, it's not letting that work. And so one of the other tools is all of this text on the window right here are actually tools that you can click on and drag. So like if you go over the slice number and you click on it and drag, you'll see that you can actually like move through the tomogram. Now, we're gonna have to use that a lot today because the scroll wheel's not working. But the nice thing about it is that this is a very thin tomogram, so there's not a lot of like movement up and down. But when you have a really thick tomogram, you can just hold the thing and scroll right off the top of the screen. And it'll like loop around. We'll see it later, but all right, bring this back to about somewhere in the middle, something close to like slice 25. And we'll look over at the right side of this thing. We can wait for people to catch up.
How do you tell if it is like in the middle?
So on this slice number, it'll just show a number right there. So I just put it on 25 out of 50. It's not critical by any means. I was just, all right. On the right side, there's this properties tab. This whole thing over here, it basically just displays for you information about the objects that you have in your workspace. And so right now we have this one tomogram. We have this eyeball icon right here. This one's important. You use it a lot. It turns on and off the display of that layer in the workspace. But leave it on. All right, let me see. I have a set list of things to go through here. Properties tab. Awesome, right? Okay.
Yeah.
Important thing to know about Dragonfly is that right-clicking on things is usually the way to go. Like if you don't know whether there's this way to do something, try right-clicking on it. Because there's almost always like an extensive menu. So if you go into the properties tab and you right-click on the tomogram in the list, you'll see this huge list of things. Now, the first thing we want to do is calibrate the intensity scales on this tomogram so that it matches the intensity scales that our neural networks were trained on. And the way you do that is by right-clicking, and towards the bottom, or maybe it's going to be up at the top right, there's a thing that says Calibrate Intensity Scale. And it'll bring up this little window right here. I'll try to blow this up a little bit. It won't let me. Now, the scroll bar, or the scroll, yeah, your scroll wheel or your slider on your laptop trackpad will sort of expand. If you put it over this histogram, you can expand and contract it. And you'll see that there's two different sliders. There's the background slider and a foreground slider. And you just have to put those where you want them to be. And I'll show you what we do. Like, to be precise, we actually set the foreground to the mode and the background to one standard deviation below the mode. And you can calculate those pretty easily by coming over here on the right side. There's a little blue button. If you have your leading edge tomogram selected, there's this histogram button right here. And that'll open up the actual histogram. Now, Dragonfly is a little weird sometimes, especially when it comes to calibrating intensities. Like, for instance, we didn't do anything to this yet, but it seems to have already been kind of calibrated on some weird scale. So what we're going to do is, you see this reset calibration. Maybe it is, maybe it was, yeah, there we go. If you click reset calibration down the bottom left, you'll see all of the values over here reset to the actual values in the tomogram. Now below it, you have this list of things, and we're just going to, you click on these checkboxes, you can get mode and standard deviation. And it'll display it down here like what the mode and standard deviation are. And so we're not going to be totally precise. I'm just going to put, if you double click on the foreground value here under raw intensity, you can just put in that mode. So I'm going to put in 137. I'm not going to worry about the decimal points. Is anyone making sense of this, or am I just talking? Okay. And then the standard deviation is 12. And so I'm just going to subtract 12 from 137 and get something like 125, right? Hopefully that's right. And then all you have to do is hit the calibrate button down in the bottom right of the little window. And you can back out of this. Your tomogram has been calibrated. You can close all of those little floating windows and just get back to the main screen. Now, what we're going to do is save it. So what I want to show you is now that you've done that work. Oh, actually, before we do that, let me show you one more tool that's very helpful. So on the main tab, there's a set of tools called window leveling. And I'm sure you all have leveled windows before. But you can drag this and actually change the contrast sort of settings. What I would say is the most useful tool is this down at the bottom of the window leveling. There's this area tool. And if you click on that square, you can just drag it over some region of your tomogram. Drag and click and drag it. And then when you let go, it will reset and optimize contrast based on that region. Okay. And the reason why it's nice to do that first is because when you save this calibrated sort of display optimized version, when you open it as an ORS object later, it will be like that. You won't have to redo any of this. So down here underneath leading edge on the properties tab, there are these 5 like blue buttons. These are used quite a bit, not all of them, but the one in the middle is an export function. And it exports everything that you have selected in the properties tab as an ORS object. So what I would do is save that tomogram you just calibrated as leading edge. Just don't worry about changing the name. And just to show you how it works, I'm going to close that. So you can just close that whole tomogram. We're going to click on the little import button, which is to the right of the little trash can icon. And we're just going to double click on that. And it's going to ask us which one of those objects do we want. And we're just going to say, okay. If it's giving you, mine was giving me some like pop-up that said, this model is, or this object is from a different version of Dragonfly. Have any of you seen that? All right.
Can you just briefly say how you closed the tomogram?
Yes. Yes, good question.
Okay.
It's not actually that easy to do, or it's not obvious. You have to select the object in your properties tab, and then you hit this trash can.
Oh, okay.
I did that fast, and I didn't tell you what I did, but there is no like. Yeah.
Okay.
And so everything we're going to work with from here on out is an ORS object. I already have them saved. We're going to import them through that mechanism right there. Yep. Yeah, trash can. It might be done.
Can you show how to draw the objects again? Draw the objects, the rectangle, save the objects.
Yes. This thing right here? Oh. So what do you need to know? I don't understand.
I closed this window and
Okay.
I don't think I saved the object.
Okay. Don't worry, I already have it saved for you. You don't have to worry about it. I'm just trying to show you the mechanics of this up front so that when you go back home, if you want to use this, it's like not going to just be a bunch of weird mysteries. Hit import. Next to the trash can, there's that import button. Go up one folder in Tomos to this ORS objects, and there's one called leading edge.ors object. If you forgot to save yours, just open that one. And it'll be in some, let's see. Anyway. Now, Dragonfly does some weird orientation things. Sometimes tomograms that you see in iMod will flip. Sometimes they don't flip. I never completely figured out the rule. When you're importing these, you can tell it how to transform and translate. Well, actually, I did figure out the rule on my system, but when I got on this instance on the cloud last night, it doesn't work the same way as mine. It's because it's an older version, and I'm not sure. All right, so we have an open calibrated tomogram. Let me make sure that I'm not missing anything critically important. Okay. Before we move on, just one thing. Forgot how you do this. There's a couple of hotkeys you should probably orient yourself around if you're going to use Dragonfly. Like, and then there's some hotkeys that don't exist that you really wish did exist. Like the contrast tool doesn't have a hotkey, but I use it all the time. Okay. Z. Can anyone imagine what Z does? It's zoom. If you click Z, it'll give you this little magnifying glass, and you can click on and drag to zoom in on your data set. If you find yourself wanting to get back to the original view, just right click on it on the image. Come on. And click on the XY coordinate, and it will go back to the 0 sort of setting. All right.
When you find it's still on, right?
So the tool will stay on. Another tool that's, did I unmute myself? No? Okay. Another tool that's useful to use is the X button right next to Z. It will change it to a translational tool. So if you click and drag, it'll just move. So you can zoom in and then click and drag around. Is there anything else that's really okay? Escape. Escape brings you to the just to the standard tool. I don't know why mine's behaving so strange. We don't have any three-dimensional stuff up right now. This tool, when you hit escape, lets you rotate like a three-dimensional object. And we'll get to it in a second. All right. Let's do some hand segmentation. Oh, no. Let's crop things first. Okay. So I figured the first thing we would do is just learn how to hand segment some things and how to take that data and train a neural network with it so that you can run that neural network on the rest of the data or other tomograms. All right. So leading edge, let's see. If you right click on the tomogram in the properties tab, you will notice that there's the second option down is called modify and transform. I use this a lot, specifically for cropping. So if you just hit that crop, it's going to put you into the cropping tool. So up in the top right now, it's no longer the properties tab, it's the dataset tools. You can switch between them. So it's not like your properties tab didn't go away, it just added a new one. And then you're looking here at, it's asking you, where do you want to crop it? Now, there's a couple ways you can do it. One way is to just, in the middle, you'll see that there's like there's actually a green square around like a boundary box. And you can click on the boundary box and drag the boundary box. And you can click all four corners and you can make this thing the size that you want it. But I suggest what you do is just put in these values. I'm going to zoom in on this. See under cropping here, there's X, Y, and Z. Those are min and max values that if you put them into those boxes on the right-hand side, it should just crop out exactly what we want. I know they're crazy numbers. I didn't make them nice round numbers. That work for anyone? All right. Now, let me know if you need those numbers back. I'll go back to there, but what I wanted to show you was, let me do it for myself. 35, 434. Uh, 288, 687. I think this is going to do something weird because it's going to be weird because this thing is on this old version of Dragonfly. It's importing these tomograms in a different orientation. And so these values that I figured out when I was doing this back home are probably not the right ones, but we can get past it. I'm just telling you what's going on. So let's go ahead and use the same coordinates just so that we're all on the same page. All right. You see this, you can click and drag on that middle like handle of the box now and drag it to wherever you want it to be. I would drag it somewhere like here. I would try to get, this is like where you as a human have to figure out what do you want? We're gonna look at microtubules. We're gonna do a network that tries to find microtubules and ribosomes. So I just pick a spot where I could like get both of those features. But obviously, you know, if you're training your own network, you got to figure out where those features exist. And sometimes it's hard to find them all in like one small spot. And you might need to cut out multiple chunks and train that way. But once you have that, just hit apply on the right.
Once you apply the cropping region, is there a way to get the green box back? Or do you have to like undo the crop?
You mean like fully expanded?
Well, like I cropped the first region, but now I don't know how to move it to a different.
So sometimes the box disappears.
Yeah,
and I don't know how to find it all the time.
Okay.
Like this is just one of the quirks of this thing.
Okay.
Sometimes.
I mean, it's cropped, but it's.
Perfect.
Okay.
You don't even need it. I actually have a cropped version saved. You can literally open it.
Oh,
I just want to teach you how to crop.
okay, got it.
Hey, somehow made my tomogram upside down.
That's okay.
Okay.
Actually, that's more the right way. That's how my computer runs. But like, you can right click on it if you want it to be the same as ours. You go to flip rotate. Probably maybe it got to flip. Or has it always been a way?
It's always been its rotation.
Just crop anything. We're gonna pull up. We're gonna go to plan B and actually just pull up already cropped data, but I want you to know how to crop.
Okay.
Yes. Oh, I see. Yeah, people's are flipped in different orientations. So that's not too helpful. But I'm not sure what to do about that. Probably some preference inside of the actual instance. So, okay, let's do this. Don't worry about where it is. I just want to show you how to crop a chunk of this tomogram. And what you do is after you hit apply, just put it anywhere and hit apply. And then if you go back to your properties tab, you'll see that you have now an object called leading edge cropped. And you don't see it because the eyeball icon next to it is shut off. So you need to turn off the full leading edge data and turn on the cropped version.
I have another question.
Yes.
Can you explain why we went from 50 slices to 1?
Yeah, sorry. That was in here in the Z
Oh,
for the
okay.
cropping, but don't, it's not critical.
Okay.
So I was just trying to use a very minimal piece of data and to show you how little data you had to like use to train a network.
Okay.
But you can make it any size you want. All right. Go back to the viz server. All right. So for those of you that things didn't go completely straight for, if you go to import on the right-hand side in the properties tab, and you go up two folders back into the NYSBC Dragonfly data, there is I believe it's the training data folder. And there's an object called NYSBC training data. Now, we're going to hit OK, and it's going to import 3 objects. One of them is the leading edge cropped. Now, make sure everyone's on the same page. Okay. And what time is it? I want to make sure I don't like completely lose track of.
132. Yeah.
All right, so we're going to just talk a little bit about the hand annotation tools. But I hate hand annotating, and I find the easiest way to do it is to denoise your data first, and then use the tools that like work good with like high signal to like extract specific features. And so click on this leading edge. Actually, yeah. Now, I forgot. We should have done something at the start of this, which is to load these trained models. Let me think. Okay. I'm going to show you how to denoise things. I'm even going to show you how to train a denoising model. But for now, there should be a little cropped version called inference deep clean. That is the same chunk of the leading edge crop tomogram, but it's been cleaned or denoised by one of my models here. And one of the things coming up is to show you how to train one of these models and how to use it, but I think it works wonders for just hand segmenting. And so what you're going to want to do is click on the segment tab. I am going to close these. I think there's 3 different things. Okay. We want ROI tools. And there's this, the way you build a region or an ROI is to just click this new button under the basic tools. We're going to give it a name. Call it ground or ground truth or whatever you want to call it. We're going to leave the geometry setting as leading edge. You want it to be the same as whatever tomogram you're making it on. We're going to create it as a multi-ROI. So we want to have multiple regions of interest. We're going to have microtubules and ribosomes and background. So that's 3 different classes that we need. So on the right-hand side, just change classes from 2 to 3 and hit OK. And so you should see after that in your properties tab, something called ground. And if you select it, whoops, you'll see that it has down here on this, the 3 different classes. They aren't named or anything yet. You can just double click in these and name them whatever you want. Or I'm going to call the first one microtubules or just MT. I'm going to call the second one ribo. And the third one background. Now, well, I'll wait till everyone's done with that, but when you go to segment something by hand, you just have to pick on the right-hand side what class you want to segment. So we're going to start by clicking on microtubule so that it's selected. And then on the left-hand side, still on the segment tab, I'm going to close those ROI tools. Like I'm going to close it and open ROI Painter. This is where all of your tools for painting things exist. And to be honest, all you really need are these 2D tools. Down here, there's this thing called 3D tools. And that only works when you're segmenting in actual 3 dimensions. And no one really does that. If you want to segment in 3 dimensions on your tomogram, we actually, instead of using a single slice, we use the multi-slice tool. It's a really important kind of thing to know that these two exist. But then you have right below it, let's go multi-slice. And what that does is it's going to just reach across whatever your brush width is. It's going to be like a sphere. And so it's going to, go below and above the screen. Multi-slice. Select the circular brush. And then right next to it, if that's not working for you, if you can't select the brush, let me know. Because sometimes you have to have other things selected. All right. So in the drop-down menu, there's 3 different tools. There's the full brush, the adaptive Gaussian, and the local Otsu. Full is fairly self-explanatory. It's just like you drag that tool and it paints in everything that it covers. And you can do that. In fact, I'll just show you real quick. You can do it. You can see that you have this brush now. And if you hold the control button and scroll, and oh, come on, please work. Okay. Oh no. Yeah. One of the really convenient things in Dragonfly here is that if you hold control, you can scroll your mouse wheel and it will just adaptively change the size of your brush. And so while you're painting, you can just very quickly do that. But man, over these, with these cloud instances, it's very difficult to sort of pull off. Okay, see that huge, like we can sort of scroll up and down. Now, if you have a full brush, my Dragonfly just crashed. Yours crashed? Yours crashed as well? Oh man, that's not good. I did this last night. I did this just to test that it was gonna work. I'll restart Dragonfly. We can get back to where we were quickly. I have it all saved. It does, I wouldn't say it likes to crash, but when you do things to it, it does crash.
How do we know the connection sort of?
I mean, just like shut up.
Oh, but like this was. Okay.
All right, where the heck were we? We were at NYSBC training data, I believe.
So I'm curious that I forgot same meeting with PC.
We didn't save anything. Okay. I do want to show you how to manually paint things, but to be honest, I have saved training data so that we don't have to like manually do all of this. But I didn't want you to go home without doing it once. Let's see. Go back here. I'm going to make a multi-Roy under the ground. Oh, wrong. I didn't make it a multi-class really. If this crashes again, we're just gonna find another, we're gonna find a way to move past it. I just want to try it real quick. Well, it's working now for some reason. Okay.
Open the NYSBC training data
Open NYSBC training data.
on the training data portal.
Yeah.
You just keep drag control.
You have to hold control.
Oh.
If you don't hold control, it will not add new features to your class. That's working. And if you hold,
Oh.
this is one of the weirder things they do, so let me make sure you figure this out.
Well, you don't have.
The reason why you can't click on it, you Dragonfly, if you don't have something selected that it can manipulate with that tool, it won't let you pick the tool. Now, it's kind of nice because then you know you can't use it, but like, also annoying. So if you select the multi-ROI or the what I call the inputs in the saved data, like either one of these, it should then allow you to actually select. Actually, you select your ground, then you select this. Yeah. Okay. Should we go back through making the ground truth the ROI? Yeah. Like, I know I don't have like a walkthrough up for you, so please just tell me to.
Can I have a? Someone, I just.
I'm gonna delete this just so that we have to do it all from scratch. All right. So,
Does it keep popping up?
Yeah, I tried to put like X or OK, just, I don't know.
Alright. so to generate a multi-ROI and the ground truth, go ahead. You have questions?
Oh, God.
Yeah. I don't know. Right click on desktop.
Say that. We haven't made it. We made it earlier, but then it crashed.
She did otherwise.
So it wasn't saved. Right click on this real quick. And then go to Epsilon.
Just shut it down so that it.
Now, this is the input that I say, so we can just train something with that, but.
I get on like crash reporting mode.
Things crashing over there.
It crashed and then it wanted me to report the error in an email and it just wouldn't let me
I see.
close out of it.
I see. So for those of you that can do this right this moment, I'll just go through it one more time. On the segment tab in the top left, under ROI tools, it's hard to see. They just put it there. This little button that says new. Under, like right at the top left. Do you see that? If you click on that new button, it'll open up this window for you. And then you can call this whatever you want. I like to call it ground. And I create a multi-ROI by clicking on this little checkbox here. And then that allows me to tell it how many classes I want. We're just going to pick 3 right now. And it should generate this object called ground. And it should have 3 unlabeled classes in it. I'm going to call it microtubule, ribo, background. Now, if you're particular like me about the colors of things, this is a good time to change the colors of things, because as soon as you train your network, and it has colors built in that it likes to output, it'll always output those colors. And you'll have to manually change them every time if you don't want them to be that color. So right here, there's a little thing. You can just pick a color from the palette that you like. Doesn't really matter. I always go dark blue for microtubules, orange for ribosome. And I like to use white for background just because it's like the least obscuring of like the view behind it, but none of that matters. So let's try. Does everyone have a multi-ROY open called ground? All right. Select the microtubule class just by clicking on it. And then come over to the left side. We're going to minimize the ROI tools and open up the ROI painter, where we're going to select the round brush. And we're going to use, we'll just leave it on adaptive Gaussian. Now, when you bring your mouse back over the middle part of the screen, you'll see that it should look like a brush. Does everyone see that brush? Okay. Man, if you hold Control and you click with that brush, it will just add things. It crashed? Oh no. All right. Is that working for most people?
How can we unselect or?
Holding Shift and clicking on it will deselect it. It crashed.
Yeah, again.
Oh my gosh, I'm so sorry.
That's okay.
I don't know why mine did too, but then it started working. How about we're going to skip the hand segmentation for a little while. We'll just go right to what I had, but let me just show you real quick the kind of things that it can do. So, right, denoising and using adaptive Gaussian lets you pretty quickly just like zip over something and get it. You know, if I wanted to get these ribosomes down here, I could just click over, make it about the size of the ribosome and click on it. And you get like the whole thing in 3 dimensions. And so you just have to like kind of walk around and click these. Now, so you could do this in about 5 minutes. What we'll look at here is there's one called inputs. So if you leave the tomogram on, you see that other, when we open the training data, I don't know if everyone opened it. Do you all have inputs there? Sorry, I called it that. It was late. Should say ground or output. I'm going to call it output. Okay. So we don't want to train our neural network on the denoise data. I mean, we could, but we're going to train it on the regular sort of noisy tomogram. And so the first thing you're going to do is open up this artificial intelligence drop-down menu, and there's a thing called deep learning tool. This is where, yeah, this will be. I figured this might be a good time to take a short break while we can get in network training and like, do people getting sick of sitting here? Okay, just want to make sure. I know we have an official break, but. So have you opened up the deep learning tool? Okay. So probably you don't see anything in terms of networks in yours. I have like a bunch of networks that I've already imported. You're going to click on the new tool, the new button up in the top right corner. And that's going to drop down this model generator. And how many of you have done deep learning before? A little bit. This is where you pick like the actual network architecture, the kind of model that you're going to build. under the architecture dropdown, you can see that there's actually quite a few built-in kind of models already there. It's by default, it's selecting UNet. That's what I use for everything I do. Now, the next thing down is model type. We want a semantic segmentation model. There's actually two different types. You can pick between regression and semantic segmentation. But let's start with segmentation. Let's tell it that we have 3 classes. So let's make that a 3. Input count is always, not always, but like it's 1. Like your general UNet's going to have 1 input count. And then they have input dimensions. So I like to use 2.5D. I think it does help without really putting a big strain on the system. What this does is it takes, and so your image, your tomogram is going to get broken into a bunch of little patches because you can't feed the whole thing through the network in one go. So it's going to get broken into a bunch of little patches, and those patches can be 2-dimensional, 3-dimensional, or 2.5 dimensional, which basically means that for each slice in 2 dimensions, it averages that many slices like above and below. So it's kind of like a quasi 3D thing. Not at all. Okay, so number of slices. So I always crank this number of slices up to the highest possible number, which is 11. It'll work well either way. I just feel like 11 in our hands, you know, we get as much information as we can. Okay, we're going to name this, I'll just call it UNet. And I'm going to hit enter. And it's going to generate a model with random weights. It should only take a few seconds, but I have seen it like crawl for like minutes before. Let me know if that's happening. And then you can close this model generator and you get back to the deep learning tool. Now, does everyone have a network called UNet now? All right. So down with it selected, down at the bottom of that window, you have this 2 buttons, go to editing and go to training. We're not going to do anything in editing. I'm just going to click on it and show you that you can actually see the architecture of this UNet. You can see the descending sort of, I forget what they call this branch.
Encoder.
Yeah, the encoder versus the decoder branches and stuff like that. If you really want to, you can go in here and edit through like visual means every layer and every like kernel within every layer. I'm just letting you know, it gives you a lot of control if you want it. So next to the editing, go to training. This is where we're going to set up training. So in deep learning, or at least in Dragonfly, they refer to the inputs and outputs of your training. They refer to your training set as inputs versus outputs. And so our input in this case is going to be the raw tomogram or the cropped version that we cut that piece out. And the output needs to be the segmentation that we made or that we opened. It's either called input or output, depending on what you. So under input, select leading edge cropped. And then under output, I know it came in as input, I apologize. Now, that's literally all you have to do. You have to just give it training data. But there are a few other things you can do. And what I'm going to ask you to do is under training parameters. So you see there's 3 tabs up here. And the middle tab is one called training parameters. And for whatever reason, they used light gray on dark gray text. And it's hard to read, but the top one is called patch size. If you double click on the number, it'll let you like change that number. And that's the actual like number or the size in voxels of that patch that's going to get cut out. So I set this to 128 for this data. Stride ratio is like, go ahead. Yep. You're gonna scroll down on the window here. Or no, this one here, it's kind of hard to see. We need to scroll down below this part right here. I wonder why it's not. Let's see. This, let's see. Let's try and do that one more time. All right, everyone.
Yes.
I don't know that you're gonna be able to help, but maybe you can help them try to figure this out. It won't show the bottom like if they go to train. And there's no scroll like bar to get.
Yeah, it's because it's like inside the window. Can you?
Alright.
Oh, you just never. Read back to that, just, yeah. Okay. It's like inside maybe.
So click on go to training. And then up here, this is the input. This is going to be your noisy tomogram called leading edge crop. And then under output, click on that. You're going to give it that thing called, oh, actually give it inputs. Yeah. I know that's weird. All right. Okay. The only, forget stride ratio. Basically, it says like, are you going to take out patches that aren't overlapping or are overlapping? So if you want overlapping patches, you need more data. Say you have a very small data set, you want to like get more quote unquote out of it. You can turn the stride ratio down. So like 0.5 will mean that they're 50% overlapping. Batch size means per sort of round of like each discrete round of training, how many patches is it going to see? They leave it at 32 by default, but I like smaller numbers. Let's just change it to 8. And then you should be able to hit train. Well, let me at least point out the fact that below the batch size is epoch number, which means how many total iterations is or cycles is this going to train for. 100 is a nice default, but sometimes you will need more than that. In fact, let's give it 200. Sorry. Then the loss function. The loss function is the actual function used to calculate how well the segmentation is going and to decide whether it's getting better or not. And so there is, you can double click on this and there's a drop down with a lot of different or multiple different loss functions, but categorical cross entropy works for everything that I've ever done. So I'm going to hit train. I wasn't going to actually train anything while we were here, but then we got these online instances and it's actually not too slow. I figured I would, because yours already training over there. All right, cool. Any questions to this point? Because we'll have a few minutes, we can talk about some stuff. Feel free to go to the restroom, get a drink.
What was the input output you're supposed to select?
Okay.
Yeah. I could now go to.
Okay, yeah, right, and, online, I look online. So, just figure
I already have all these numbers, right?
So. So just bringing actually both devices into it, then it goes, that's what I experienced, you know?
I wanted to send you back
So.
better Dragonfly.
As of.
Yes, it's already success.
Drag that background.
So this learning curve is not gonna look great, okay? This is a small amount of data and it's a quick and dirty network, but in general, you should see this go down. The green line is your loss function, and then the purple line or pink line is your validation loss. So what happens is your data gets split into two chunks. I see people work with some.
So we want to do is low. Example, for us, data. There's no. I actually guess.
Every time I try to get them confused.
Click on that animal.
Yep.
That is so.
Oh, okay.
Go down.
Oh, you want it to go down.
Yeah.
You have three classes.
So.
One more time. I don't know why you have so many of these. Okay, so your crop box and your ground truth have to be the exact same. So I don't know.
The first step you should do is assign everything.
I don't know.
So I just want to get back into project where it's far away to.
I don't know what any of
Like,
these.
yeah, and then they around the axis of, you know, just assign basically from the back to the
How does this one? Then I open up.
Well.
Do you want me to find an output?
We don't need any of these.
It always scripts and puts it on the company next to it. So the company has to take.
If this doesn't work with it, then I don't. They have to be the exact same dimension.
Well,
So like,
if
if the thing you cropped was a little bit different than the one I did.
And so what it does is the output is
It won't
based on of whatever you put into the input. So you might just have a slightly different. Yours there.
Yep.
But if you have the back side. You're gonna see it, you don't fully input it. You go away, I think it's a lot, but you just go back.
And you run out of the hands.
So that triangle indicates the last save point, right? So like, say, this was the last time that it was like, sometimes it goes up or down, like you'll see mine is no longer. It's because it went up. So it's keeping this model, because this one's better than that one, but it just went down, so it's gonna do that. It's just tracking it. Yeah.
Usable.
Exactly.
Oh, you mean that?
I just have a couple general questions.
Yeah.
How, like, the license to run Dragonfly?
Well, yes,
You do, but it's what you also.
Oh, it's free. Okay, how do you go about? Like just on the
I can
website?
send you, you just go to their website and there's,
I thought it pulled it out.
it's like a demo.
Oh, okay.
You get the demo, but you can there's a demo, but there used to be a thing that says,
Inserts into the cassette.
if you look up
Somewhere
non-academic
like that.
academic license,
Okay.
Dragonfly, it should bring you to a page.
Okay.
Comes out of.
It is available from there.
Okay, but you don't see one. Oh.
And then.
You just have to once a year, let them know that you're still
You're still
using it
using it, that's
academically.
And all that
And then
stuff
does
goes in
this
and out.
software only
Cassette,
work to analyze
That's
homelessness? Okay, because I do, like,
Yeah.
electronic copy, we do for this, so I
Yeah,
have
and then
these
it goes
serial
up and
sections,
down,
and
and
then
It's perfect.
we've been
and
looking
then
for a tool that would help us segment out the inside the cell, so.
I can tell you, but my, I student who graduated works with Thermo now. That's like her job.
Really,
She just, like, that's what she does.
The gripping
That would
is on
be
the edge,
really
so.
Yeah.
because
It's
we
like this. It
are
will
not
grip
in
what
the
it
processing
is,
lab,
however it
we
Yeah.
do the web app
goes in.
stuff, but
And
obviously,
the red
we're at a point now where we
these,
kind of
so
need to
you
figure out how to
can
quantify
play
things,
it, you know,
and
it's
it's
like-
super hard for us to just start from scratch with training and everything.
Yeah.
It made more sense today, so.
It
talk about it,
is.
Yeah.
Yeah,
Training the neural network outside of Dragonfly is
When
really,
you load it
yeah,
into
I could see
the
that.
Oh,
I've
So
done
this,
it
you
like,
made it look really easy today.
because I'm,
Yeah, that's the whole point. So this is obviously.
I coded the units and
Sets
like,
similar.
Okay.
and it's
So
like,
when you push them into the cassette, load it under the.
It's not-
in
unless you're just
basically
not doing it all.
Right, yeah, I mean, we were like, we'll just call it qualitative data, not kind of
The idea is you push. them
quantify any of our
down, they
images.
should hit.
No,
We've always been looking for a way.
We're still in volume.
Yeah.
Probably designed with volume imaging in mind
And
more
then
than
the regular
prior.
image, you can.
I- okay.
Yeah, yeah,
It's just, it's just doing that.
Okay.
People have done so.
I know, this is about to say. Abby,
Yeah.
yeah,
I
I'm
mean, you can imagine they certainly realize that problem, right?
Oh, I was.
You're gonna take 12. That's enough.
well, UK, yeah.
Yeah, I have a friend that's,
Yeah, and that also.
she's in the microbiology.
What's her name? Okay, that makes sense. Oh, that's
I
okay.
totally know. Area.
Priority on.
It sounds really familiar. I'm in the Department of Physics, so.
I think she's in like, she could even be like,
Okay.
But I don't think
she's been working on like the bacteria
Okay.
that like cause problems.
So this is.
That
our
one sounds familiar,
says-
but I couldn't.
What it is there.
Cool.
I've been meaning
Doesn't
to
show
show
it in
it.
there.
Yeah.
So something about this newer one that's for the measurable is designed so you can measure a certain thing.
Okay.
Yeah, I mean, so.
It should,
Go to that.
It's not like it could be something else.
Yeah, I don't know how far.
So the way it trains is that it trains until it stops, until the valve.
By the way, I'd like to also.
It trains until it hits that number.
Yeah.
Until it stops.
Oh, it is.
Yeah.
So it will stop itself when it stops getting it.
Oh, I don't know what you're saying.
You can change that too, you can set it for
Okay.
but by default.
So if you set the triangle, like, it's still keeping that, so it's the last best.
But I found that between like 50 and 200 epochs is like pretty good for most things.
I was stuck out radically.
Another
So-
question. How do you?
That's your final language, that's not normal.
We're gonna go.
We will.
You would normally just run it again.
I just.
No, no, that's okay. I just thought I missed something.
It's still equally last.
Yeah.
This has
So
all
anything that's
this input data, so.
Yeah, you know, so yeah, I
Are not
do
going
this,
to
yeah.
But it's like, that still might be good enough. That
Yeah,
last
so this is
good
actually
check.
like, I
Still
did
be-
it, I did like this myself.
Yeah.
What
roughly is the y-axis?
Very.
Like,
What's
it
your,
really goes up.
what's your gun?
It's bad,
Okay.
okay,
Can't.
for all metric speeds, Does a higher score is a higher loss.
Yeah, so it's saved, it doesn't save it
Whatever
in the web file.
network is
It has
currently
a certain
uploading
specific
and
file.
the
So I can
then,
read
I don't
that.
know, subset
Like,
plus, but
they don't, they just save it, so.
I
It's like this
have
whole
no
like
idea
thing I
how
have to
any of
go
the loss
in
functions
and
are calculated.
have a
Yeah,
list
so
of
I want to
takes up
calculate
a-
how it's
a
higher
XML
band.
file.
Yeah, higher than set
And then I like put them both on the monitor sheet and knit it and modify it using
Any
the
decrease in
coordinates from that.
self-visibility.
Yeah, cause there's a header.
We do really expect, well, I gave her, something we want to have to
So the.
I'm still in just a little while.
So mine went and it's backside of this.
An accidental truth, the untruth, because there's nothing worked to it. So we spent about 6 months working on like each format between. It's like version X, my system was
Well, the export,
We only export things and it has.
So whenever we got the import filter work, it didn't work my next time. Right, machine next, they would rotate the data. And the histograms are all off, and you got it to work, it's not perfect, you may like it. Now, like that, but I'm not saying it's employable page, but
I just, so what I do is I just do, I just make a, like a, I look up like a script that just reads in, reads in the web.
oh,
Reads in the web, reads in that
You want
XML
to
files, and then outputs a specific, like I messed around.
Do you write up header?
Well, what I do is
I hope that.
I make a folder tip and write in.
With that, with the
Yeah,
correct.
so I read in the pixel side from the lip and then.
I think we need to buy you a script.
Oh, that's Carolina, yeah.
So yeah, and it's
That's
just,
actually very interesting.
cause then it
We
like,
had to do some weird, we also have to things to.
Oh, it gets really weird. So-
maybe not.
I also do have that in select, so you can do that, so that it looks like that, you just want some.
Is this, if you use like another software like AIS, I know they have like a UNet, like, they have like similar, like rural methods. Would the output be like comparable, or does Dragonfly do something like?
Not, so
At the end of the, in one.
there's all kinds of variation in the architecture of neural networks.
Okay,
But not like,
Yeah,
right
so
up
it's
here, like, if a unit is a unit, there are.
Thing in maps is.
different unit?
No, that.
You can have little filters that increase different aspects of it.
You have the-
I think they have like modified theirs to be as good as
Yeah.
possible. Because I've tried coding my own, and they do all right, but they never get as good as theirs.
Yeah, okay.
Sometimes it can.
But those are my own,
I don't want to wait for the process.
it's high for, yeah, and then sort of flow, it's kind of like. make it-
Yeah.
So yeah, I never.
Very unoptimal. So I think there is some. I don't think it's like, it's not proprietary.
Yeah.
All of the technology.
No,
I don't know, I would put it with one of their reports in a way that allowed me like to look at it.
Like, let's together.
So this.
I don't know AIS, what is that?
Well,
Yeah.
get down
But
policy
yeah,
world.
Oh my god, I didn't even notice that.
Like, this is easier, like, they don't. It's written about, so cool on this anyway.
So it's fundamentally doesn't really-
Table instant segment.
Daily unit.
It's like you, it's a little similar, it's like, but it doesn't have all the fancy stuff. And the idea is like command drive, and then you use Windows, give it like a top and then a hit until like a certain space.
Yeah.
And then you give it whatever drop down network.
See, there is,
Yeah.
what I basically use is just the effects.
So,
and just do it.
Sounds cool. I'm not familiar.
And you had.
Yeah, it's,
Essentially.
Yes.
I got into Dragonfly because I'm not,
But it's nothing like special, it's really.
I remember the paper, to be honest, but I haven't like.
yeah, I was just wondering if it was like, it's like, seems like very similar ideas with a different platform.
I'll have to read it.
No, it's totally fine.
Yeah,
I, since my lab was private a little bit, I.
It's like 2 workstations that everyone moves to the.
All right, well,
Yeah.
So I'm just like,
I'm just trying to say that.
technically we can stop this and move on anytime we want, just so you know, but I'll let people filter that into the script.
And I believe that goes in box. Sit.
No, so like if I do the, I'll do that all the collection one day.
Yeah.
And it'll take a long time to save, and then transfer the PC, and then usually that night I'll just. HPC to my workstation, so.
Yeah.
It's like a couple hours.
Something. Don't all.
So, and then the next day I'll just, the.
There might be something different about that.
Yeah, but you know, it's also like.
Any.
No, that's.
But you do need to know
Well,
There's a lock right now.
So you know,
almost done.
I use threshold.
It should be pretty.
And then you do. It's Reggie stack or just his stack?
Yeah, just this.
Just so it's clear,
In the car, and actually,
these things will change. You set it to 200 epochs or 100, whatever it is. But it has a patience parameter set to 15. Means if it doesn't get, so if there's at any point it doesn't get better for 15 epochs,
So I have like.
it'll just stop training. We'll assume that it's starting to overfit and that it's not getting any better.
If we for our own
So,
data,
yeah.
how should we set up the crop size?
Yeah,
and,
so it's like, it's needed right
how
now.
many
so I
feet
think-
the pen will train?
So
It's like, and I just,
I tried to show you what I think is like minimum,
little things like copy and paste.
The more the better, but-
Take time.
but
Take file, which is.
I wouldn't spend too much time hand annotating. Like,
It's nice that separate up.
I would hand annotate a small piece, similar to like what we did, 400 by 400 maybe. Run, infer the network,
Very easy.
see how well it does, and then we will take, you can take this initial output and correct it, and feed it back, and sort of do an iterative loop.
And look at the other thing where.
So you can add more data a little more easily.
Because then I can join the CSAT, just look at the CSAT going, and be like, okay, here's the thing. And go back and forth, back to this, in the art. Yeah, so it's like, I figured out. So, yeah.
You the most, main user of, that's good, the most,
Yeah.
but that's like the most great, very good.
Yeah, so you got, yeah, so for that, he mentioned when you go, you. It's just one.
Oh, yes, yeah, well, that's the problem. It's like mine, so it's down there, that's it. Very nice.
Yeah, so if he's been go down that, like, the center and Sean has to. Yeah, yeah. He's like, so.
Well. Pretty much everyone ready to be done with this training part? I didn't come here to make you stare at training sessions. I just figured since we had it, we might as well train one and take a break.
Yes.
Let's see, you can also end the training anytime.
Yeah, you can just hit stop.
Oh, you're thinking like,
You want to fit.
And you can always restart it, like it's not hard.
It's a little square.
Save the result. It saves this for you as it's going. So, yeah, it's auto saving. Anytime the model gets better, it saves it. That's what that little triangle indicates actually. It's like the last checkpoint that it's saved on. So I'm gonna hit, well, if I can even find my stop button. Let me see. Didn't do anything. There we go. I maximized it. Now I can see the stop button. So I'm gonna hit stop. That is not a beautiful learning curve, but it is a learning curve. It's mostly because there's not a lot of data there for it to learn on, and so it's. But all of this gets saved automatically. You can always come back to these images of the training curve and things like that, so you don't have to close anything. But you can export it through this export button, and you can actually export. There is a way to export a movie of this. I forgot. Maybe it's not in the new version. Anyways, so just close that. And then we're going to close the deep learning tool and get back to our Dragonfly environment. Now, I'm going to select all of this stuff in my workspace, and I'm going to close it out with the trash can. To select it all, you have to hold Shift to do like a kind of like you're in Excel. Now, I'm doing that because I want to import back from my Tomos leading edge.mrc. All right. Let me know that's not working for you. All right. So you want now to infer this network to the tomogram and see, like, did it actually learn anything? And we'll infer it to the whole tomogram. So on this segment tab, if you minimize these ROI tools in Painter, you'll find this segment with AI section. And you should be able to select the model that you just trained. I have a bunch of models, but let's see which one I have. Now, if you can't, if it's not letting you select a model, it's because you probably don't have the tomogram selected on the properties tab. Everyone there? Or am I? All right. Once you have the model selected, you literally just go down here to this segment button. And it's going to ask you, and you're going to have to tell it the full data set. Then it's just going to infer that model to the full data set. So, yes, I have a tutorial that goes through generating simulated data with CTS, how to open it in Dragonfly and train networks. This one with all of the hand segmentation stuff, still finishing it, but it is close. And I'll get it to you after this workshop so that when you go home, you actually have like a walkthrough kind of step-by-step thing that you can just hand to anyone else in your lab and teach them how to do this. But so what did we get, right? Like, no surprise, it did okay. Did everyone's actually infer? Okay. Now, it's not perfect. You'll see that it's finding things outside of the cell, like on the carbon, like weird little membranes are getting picked up as ribosomes and stuff like that. You can, I like to click on the segmentation in the properties tab, and then go down to the background class and just turn the eye icon off, and you can actually see the data now. You can sort of see where it's doing well, where it's failing to find things. But say you wanted to make this work better, right? You don't want it to find these little vesicles out here, right? Like that's all false positives. All you have to do is come back in here, crop out a little piece with some of this noise in there. Remove that, push all of that false positives into the background. We can do this. I just don't know. I guess we'd have plenty of time. Okay. Actually, we'll do it on a different tomogram, but. So that's the tomogram that it's seen though, right? It hasn't seen, it hasn't seen all of it, but it's seen a good chunk of it. So it's like no surprise that it works already. If you go into your Tomo, if you go to import another ORS object, I have this one called microtubule ribose Tomo 1 or MT ribose Tomo 1. I was just going to say, well, what happens if we infer it to a tomogram it's never seen before? This has mitochondria, microtubules, clusters of ribosomes, but a lot of other membrane and other just stuff in it. So this has already been calibrated. Pixel intensities have already been calibrated on this tomogram. So you don't have to do that. But if you had to, you would right click on it and just go to this calibrate intensity scale. And you would set these sliders to the mode and the standard deviation below it. Now, to be honest, I do this very fast. I don't even actually calculate numbers. I drag the foreground to the peak, and then I drag the background about a third of the way to the tail or something like that. And that, it's not precise, but it'll pretty much get you into the right ballpark all the time. So, but this is already calibrated. You don't need to do anything. All you have to do is make sure you select it in the properties tab. Otherwise, Dragonfly doesn't know what it's supposed to run or infer the network to. And then you can go back and hit that in the segment tab. You should be able to just click segment full data set again and let it run on this stuff. I actually don't know exactly how it's going to. It kind of does. Now it's pretty good.
Yeah.
Yes. Yeah, it's all background. Okay. Okay.
Check the calibration.
We should check the calibration, but let me also say the network I just used was one that I trained at home that ran for maybe more epochs than yours did. I don't know exactly how yours is going to work. You do have this network on your instance, and we can import it. Let's see if we need to. Did it fail for anyone else? Like did it completely fail to segment anything?
Mine's not done
loading.
yet.
Okay.
Yeah.
All right, so right click on that.
Yes.
And then go to calibrate intensities. Yeah. Drag that one all the way. Keep going. Yeah, go back. Yeah, try that. It needs to be, the foreground should be at the mode. And then background should be at this one standard deviation total. We can calculate that, but we're just kind of doing it by eye. But I bet it'll work. Yeah, it'll show you right here that it's calibrated.
Pretty good.
You can close that. Rerun.
Yeah, I wouldn't put this on.
This segment.
I don't, so that's what I was gonna ask.
I think
right?
it's on the-
It's the one that I-
Anyone having issues?
Still working.
Okay.
You create a new one, or did you use the same?
I just use the same one.
30 seconds.
That would be longer. Same network, so when you retrain.
Hopefully it's getting more things.
So, yeah, so when you retrain, it's basically use only the current data set.
Oh.
And you train.
I've stayed up till like, I stay up till 3 AM every night. So like half of that time is me waiting for things to for train and I'm looking at something.
Yes.
Wait. If you do it enough, it gets kind of addictive and you like want to see
Yeah.
what comes out.
Oh, this is
Yeah.
nice.
Mine's pretty good.
All right.
Great. Look at how nice.
Awesome.
We have some things. Oh, yeah, elements.
Oh.
Now it is getting, I was gonna point out, see, these are like membrane, like SER, so
Oh.
it's finding like pieces of membrane that are close together and
Okay.
getting them in micrometers.
Wait,
Okay, so nice.
I was just,
Okay.
but it is it's good network. Awesome. Excellent. It's getting also the edge of the carbon,
Yeah, it just
but
looked a little bit.
mostly working.
At least the size of the thought. I don't know. if there's a difference.
Yeah.
Yes,
Oh,
yeah, so it's like.
very nice. Yeah.
Well,
Yeah,
Don't
it's
worry.
we didn't show it any of that. It's never seen carbon before. We only showed it a little piece from over here, and so it's trying to make good sense of it, but we
I
can
mean, I
show
know
it
a little
carbon
bit.
and teach it to ignore it.
But
That's how you would do that. You would cut out a little piece of carbon and show it. But that's not a microtubule. We'll do some of that. All right.
Yeah.
Okay,
To do that.
so just so you can see the whole thing real quick in like whatever glory it is. If you right click on your image and go to the 3D window. And then you select the segmentation that you just generated. Actually, you want to turn off the background because otherwise it'll just look like a big white block. And then next to your segment, next to in the properties tab, there's this 3D button right there. You can tell it to open in 3D.
Ooh.
So
Wow.
this will give you a sense of how much noise it's picking up. It's definitely not perfect. You see all of these little points in here, but that's pretty easy to remove. It is finding these mitochondrial cristae as, and probably this one here. And it's finding weird, these must be some like clusters inside of the ribosome, but so it's far from perfect, but all you did was segment one microtubule and like 10 ribosomes, right? So I actually think it's pretty impressive that you'd have to do so little work. Now, just to show you this, so like, see how the microtubule has all that like little specks? If you right click on the class of microtubules, there is a process islands selection. And you want, there's all these different ways to process islands. I just picked the top one. It says remove by voxel count 6 connected. And it's going to ask you, what's the threshold? Like everything below this threshold, anything that's not bigger than this size, we're just going to remove. So give it a number like 1000 and hit enter and let's see what happens. Significantly better with one click of the button.
it's
So-
like a size threshold?
Yeah, exactly. It's just like looks at connected voxels and says, how big are you? And then it gets out. I'm gonna do it for ribosomes, but we're not gonna like mess around with this tomogram too much. I'm just gonna try to clean it up. Now, this is where you can maybe use, so if you now that you're in 3D mode, you can actually use the rotation tool to like drag and rotate this. You can see that a lot of the stuff that's getting picked up as ribosomes is on this other layer. I'd have to look back at the tomogram, see if that's like on the other side of the carbon or what, but anyways, you have this sort of rotational tool. You can zoom in, you can zoom out, all of the things you can imagine. If you right click, you can go back to X, Y. And for, I know it took us an hour, but you could have done that in like 10 minutes. So I have a number of things we can do. Let's see how time is going. If I transform denoise with deep clean.
Can we manually delete?
Like little pieces, for
Like,
sure.
if the threshold isn't.
For sure. Now, there is also a large threshold. Just so you know, you can say if you go into remove islands, you can say remove large objects and you give it a large threshold. But I don't find it nearly as useful. It has like use cases. But if you need to manually change something, you just click on the class itself. Like say we didn't like this microtubule, you just click on that. You go to the segment tab, ROI painter, and you have to be careful, and not careful, but like depending on what brush you use, if you really just want to erase everything, I would use full. If you wanted to try to like selectively remove just the sort of signal, use adaptive Gaussian. But basically, holding shift, I forgot to say this, holding shift, remember how you were holding control to add? Holding shift removes. Now, oh no, I thought it was about to crash. Yeah. So see, like if I go over that, it just erases that microtubule. Now, the other thing that's pretty slick about Dragonfly's segmentation tools, the hand segmentation, is you can just swap classes, like specifically. So like with the brush. So if I click on microtubules and then I hold control and click, wait, sorry, that got weird. Say I'm on microtubules and I can control click ribosomes. You'll see that they get labeled as A and B. Now, if I hold shift, it'll give me an orange brush. And if I hold control, it'll give me a blue brush. And it will only act on things that have already been segmented, right? So say, for instance, this microtubule really was a ribosome. Now, that doesn't make sense, but you could just sort of scroll over it and just swap the class. And so when we're sort of retraining and things like that, every time the network misclassifies things, this tool lets you go in and sort of reclaim that territory into the right class. Yeah.
So, is it like smart? Can it tell the slice to apply the change, or will it only change for the slice that you're on?
If you have the multi-slice tool selected, so there's the single slice and the multi-slice, it'll do everything above and below as well.
Okay.
Yeah. So if I scroll up and down, that whole thing should be orange now. Yeah.
It doesn't intelligently select all. It's just because the brush is large enough to physically cover that entire.
Yeah.
Okay.
But if you have like a discrete object, you just want to change the class up, you could just use a gigantic brush and change all of it. Then it won't be very precise.
All right. So what are we doing now? So I had another tomogram we could infer it to that it does like a worse job, and I was going to show you, well, how would you retrain a network to be good at more than just those two tomograms? I don't know how useful that is. We can also We can also just immediately start working around with some synthetic data. Or would you like to see retraining a network? Okay. I was going to do both. I was going to do both at the same time, but let's just do it this way. That's how I planned to do it originally. All right. So get back on here. Okay. Let's open one more tomogram. Let's import mitoribose tomo 2. If I remember correctly, this is one I used to retrain, but I could be wrong. All right. So anytime you can't see what you just opened, make sure you close the eyeball icons on all of the other stuff and then reopen your current one. Dragonfly likes to just not show you certain layers. Okay. So open that Tomo and go to like slice 75, maybe. Somewhere near that, so you can see what this tomogram looks like. And then this is more intracellular nonsense, microtubules, but more actin and cophylactin as well. So let's just select it and infer our network to it. If you don't want to do this, like you can just watch mine. I don't know that it's important that you do. Oh, no, it is. Do it. Sorry, I'll take that back. Because we're going to use the output from this in our retraining. And you'll see it doesn't do as well on this particular tomograph. Like, it's trying, but I think it's just a lower signal to noise tomogram in general. So it's failing to find pieces of these microtubules. Doing all right with ribosomes, but so what I would do, okay. Disclaimer. It's not simple to train a network with, so it's not easy to train with multiple inputs, right? Because when we get done with this, we're going to retrain with our new inputs from here that we hand corrected. And we're going to give it our old training data so that it sees both. But the original training data had both ribosomes, microtubules, and background. So we have to have all three of those classes in this. Whatever we crop out here has to have all three of those classes in it. There are ways to get around that, but I'm not going to do it today. And we can talk about it, but it involves concatenating your data together into one block. Because if one of your chunks of data doesn't have all of the classes in it, Dragonfly and most deep learning will just kind of get annoyed with you, but it won't work. Dragonfly will not work. And so we concatenate them. All right, go ahead.
I don't speak the limit.
Click on leading edge tone or on the tomogram itself. You have all my notes. Okay, so what would I do to retrain this? I'm going to pick okay, first of all, let's turn off the background so that we can see what we're actually looking at. I'm just going to scroll up and down and try to find a place that has some ribosomes and some microtubules close enough that I don't have to segment the whole tomogram. But this isn't the best one, but let's say, okay. I see. Let's take, I'm going to take something up here in the top right corner because there's a microtubule running through here. There's some membrane that we'd like it to ignore, and there's a cluster of ribosomes right here. Now, what you want to do is right click on your tomogram itself, go to modify and transform, and we're just going to crop it. And so it'll open up this cropping tool. Hopefully you see the box now, or maybe not. Oh, whoops. Sorry, I got thrown off my slice. Okay, all right. What happened to my microtubule? Oh, there it is.
Those are on slice B1.
Appreciate it. I thought I forgot I moved it. Okay, so the easiest way to do this is to drag from the edge of the crop like boundary box and just drag it over to include like the region you're interested in. Don't worry about the size exactly. Let's just get a chunk that includes that microtubule and those ribosomes. Now, that's the XY axis. Now we need to like set it in Z. Maybe we can just use the whole thing. Let me take a look at it real quick. Oh, hey, it's working. Okay. Yeah, let's not do a whole slice. This is also being very weird. Okay. Everyone have a crop box drawn? Okay, so what I do is I click on the slice thing and I drag it downward until I find the bottom of the region that I'm interested in. So I'm going to go to whatever the bottom of those ribosomes are until they're out of the view. And then I'm going to look at what slice number that is. It's 46 out of 162. So in the Z minimum, we're going to put 46. And then I'm going to scroll up to the top of the signal. Actually, it's the very top of the tomogram. So you can just go, well, maybe it's not. Let me hold on. I take that back. Okay. Okay, so go from 46 to 78. At least I thought that's what it was. How come that's not working? Huh. My box disappeared. I'm not sure what happened to it. Maybe it's not 7. Why is it at 110? This is very weird. Sorry. That box is in the wrong place entirely.
You may have moved after.
Okay, we're at 40.
I moved to.
I wonder if this needs to be 46. Maybe it's because we reversed or something. Let me check that. No, that didn't help. Let me try one more thing. Yeah, I have no idea what's going on. I apologize. This is probably due again to being like a different version. Well, I'm a little unsure of what to do if it won't go to the actual slice I'm telling it to. Maybe we. Hmm. Well, it's just going to crop out of. Oh, yeah, let's see what it does. Yeah, let's see what it does. Good point. Maybe it's in the right spot, but I don't think so. No, that looks terrible. All right. Well, I've never had this happen to me, and I've cropped a lot. Very unsure. Let me try just one more time. What? But it's doing it to everyone.
Yeah.
Okay, so clearly it's not going to work for me. Okay, change of plans. We aren't going to be able to do that exactly right now. But we can do something like it. Let's go to messing around with some simulated data. So what I would do is just close everything except for the leading edge tomogram. Whoops. Trash can. Just so you have, you can always reopen this, but just in case we need it. Yeah. Now, let's go to import. And then we're going to go up 2 folders back to the training data. And there's one called prophylactin split training final. Took me a while to get that one. Now, go ahead and turn off the leading edge tomogram so that you don't have to worry about it. And let's take a look at, there's one called actin prophylactin split tomo. Just turn that one on. And that should be, this is purely synthetic data. Does everyone see that? This is actin and prophylactin filaments that have just been placed randomly into a box. Now, if you also visualize the actin prophylactin split atlas, this is literally what comes out of CTS, this atlas file. It's a grayscale file with, each molecular class identified as a different grayscale value. So we're not going to go over generating synthetic data today. If we have time at the end, like I can show you on my computer how to do it. It's not hard, but I knew I couldn't get everyone to install MATLAB and like all these other things. So, but when you import data from CTS, this is what you get. But what we want is something like this like colored version that Dragonfly likes to use as a multi-ROI. So we need a multi-ROI, just like we generated for the first training. We need a multi-ROI generated from this atlas. And so to do that, right-click on the atlas in the Properties tab. Everything's under right-click. And if you scroll about, or if you look about halfway or 2/3 down, there's one that says Extract ROIs. You just hit that. It's going to pull out all 4 regions of interest. Now, I have one pro tip for you here. If you select all of those, just with a shift click, and then right click on them, you're going to get, it's right click again. You get this option, create multi-ROI from ROIs. So you're going to click that, and it's going to condense them all into a single multi-ROI. Now, before you do anything else, you still have all of those other classes selected. Just hit the trash can, and it'll just go away. Sometimes I have 30 classes that I have to deal with and I just don't want to. But you can close that, you can turn the eyeball off on the atlas. And if you turn on the multi-ROY, should be nice and colorful now. Everyone see that?
Yeah.
All right. That's setting up data out of CTS. That's what I love about it. I mean, it's like, this is, the green is actin, or the blue, I mean. This is cofillin or actin and yellow with the cofillin in green. All right. Now, we can either train a network or not. Like, we could just train a network and actually see how it works, or I have a network train that we can do. What do you guys feel like doing? It's just more of this kind of like curve, but not to like deny you training time on it. All right. Let's set it up. The more you do that, you'll go back home and you'll remember how to save and you'll never remember how to train data and all of that stuff. So, okay. Artificial intelligence menu. Go to deep learning tool. Now, click new. We're going to use a UNet, semantic segmentation. We actually have 4 classes this time instead of 3 because of the background plus the 3 other. So give it 4 classes and make it a 2.5D with 11 slices. And we're just going to name this like cofillin unit. All right. You can close the model generator. You can see your 4 classes here. You're going to just go to training. And when you click on the input, you're going to find actin, cofilactin, split tomo for the input. And then for the output, you're going to find that multi-ROY from 4 ROYs. We could have named that something, but we didn't. So does everyone see that for the output? All right. Now, the only other thing we're going to do is go to the training parameters.
Before that,
Yeah.
show them the thing for retraining, because it's the only thing that they basically is kind of adding,
Oh, I was going to get to that on the next retrain of this, but yeah.
if you can retrain, it's the ROI.
Yeah. Okay, but I have it saved, but just so you see this, if you have multiple inputs, say you have one set that you wanted to give it, and then you have another set that you cropped out from somewhere. If you just click this add new training data set button, it gives you a new set of inputs and outputs, and you just do the same thing over again. And you can just keep adding them.
Can you quickly say how you got to that screen?
This one right here?
Yeah.
Okay. This is the deep learning tool. It's a weird setup. On the bottom, are you still here?
Yes.
Okay.
Yes.
On the bottom of this, on the left, there's those 3 buttons. There's one that says go to training.
Oh, it's make it big. Okay.
All right.
Thank you.
Under training parameters, I'm going to do the same thing I did on the last one. I'm going to make this a 128-inch patch or 128 pixel patch. I'm going to change the batch size to 8. And I'm just going to let it run. I'm not going to change epochs. We're just going to hit train. And I'll help you get going.
Sorry, what should the input and output be?
Yes, so input is your fake tomogram. It's called cofilactin split something tomo. And then the training is going to be called multi-ROY from, or the output's going to be called multi-ROY from 4 ROYs. Yeah, there you go.
Yeah.
So the input's the unlabeled and the output's labeled.
Yes, yes. I don't know why that, well, whatever. Deep learning people are weird. Call them inputs and
Then you
outputs.
input, the output is the thing you have.
But didn't we give it the latest?
Yeah, exactly. It's the output that you're trying to achieve. That's why they call it the output, but
Sure.
I think they should call it ground truth or whatever you want, but it's goal. All right, so this is a slightly larger data set. It's not that much larger, it's just like more Z slices, so it would take slightly longer to train, but
Under which tab can you, change the number of training
yes.
series sequences?
Yes. Is it already trained?
Yeah, I was just kidding.
So on the basic, where
Under
you,
that trainings tab where you put the input output?
no, it's the next, it's the training parameters tab.
It is on the training data tab, but at the top of that one, there's a nested tab inside it.
Okay. I must have missed.
Yeah, sorry.
No, it's okay, it's runs.
It'll be a fine network. We just changed the size of the patch really.
Okay.
Now, we don't have to wait for this whole thing to train, but we can take a few minutes to talk about things if anyone has any questions. Not for the mask. Let's see. Yep, there you go. I would leave those all the same. Just leave them as the defaults for now. I wouldn't do any previews on anything. Just give it an input and an output. You can set it up. You can make like you can select an image or like a set of your data and say, after each epoch, I want you to segment this and show me the results. So you can actually watch it kind of in real time, learning the segment, but. Okay. Let's see, what time is it? I want to make sure. Okay. I guess technically we're supposed to take a break right now, right? Yeah. So I guess it's a good time. I know I made one earlier, but let's just take a few minutes break or however long is scheduled. I don't remember.
What do you want, 15 minutes or half an hour?
I don't need anything. Whatever they want.
What would you like?
It's maybe 10 or 15 minutes.
15-minute break.
Okay.
Oh, there we go. We'll start first and foremost.
A very weird pseudo vampires, high contrast.
I think at least like color body.
Probably not.
That would be at least.
It would be very difficult to use Dragonfly.
Wanna break it. I think it was sleep someone. It is very dark. Or it's dark.
Okay, so it's just.
Okay, so that was good.
I have doctors.
So I see. Well, so the thing is, all of them are labeled final. So I can't find what's on the ground. When I input it, they all just come in as a file. That's where I was referencing. No, because I always just deleted them all. They are different things,
But we should do.
but they're just not like just labeled. I think. And also none of them look like the right one, because some of them were like the ones with the fiducials in it.
Yeah, the real data.
Oh, yes. Okay.
So if you just double click on.
Okay, cool.
too many data sets.
Yeah. Okay. So then I train what on it?
You're the first.
Got it. That's where I lost everything.
Yeah. Really. Garbage off intelligence.
I was right.
I thought it was just like, we didn't know we had the whole thing.
Okay, cool. This is doing on the right slice, so it's not right. No, yeah, I select on.
It doesn't matter if you select.
Yeah.
Just in the deeper,
Okay.
that's where you select.
Okay.
Yeah, it does need
Doesn't.
you guys trade with. But if you, so if you unselect that, that would you're gonna put one that's this in your hand. Then you take it. So if they read one, but then they take. I did do that, but you guys like, they work with that. Sure.
And
You want to see something.
Sure. So classes should be four. One, and then the 2D5, and then
Oh, I forgot to do that, but.
actually go to 11, we'll name it a truth. Maybe truth. We know that's not the right thing anyway, so.
It's very.
I'm gonna name it LOL.
Penns, networking team, segmentation, two, you have a million things that are all like next to you.
I just called it like.
Network or something.
Okay, and then LOL. Cool, and then.
So. You know, want to certainly use that to parameters, like these right for this, when they see what's in the. Parameters down and data, but you don't need to necessarily.
Oh, okay, so even like the 64 to 128.
Yes.
Okay, cool, yeah, so I'll just leave it at whatever.
Yeah. Okay, cool.
Cool, and then. Go ahead. Yeah. I don't look at that. Oh,
That was fast.
that's not good. So.
Oh, wait.
So just do the same command.
Oh, yeah, okay, it's the next step that you like decide that product. So then
Both that makes one.
and,
No, I just tried.
Yeah, you're crazy.
Not yet. Yeah, we're gonna, there's a setting inside it.
Oh. The one that's living in spirit.
I've done it and I wasn't really planning to follow along, but now I found that.
Oh, well, those are interesting things that, because.
I just clicked on these.
So it's number one, it's red, it's bad, it has some sort of Vega. Process.
Yeah,
And I don't have
And it seems like this doesn't happen, so. He's very.
We're sure they're across town.
Oh, yeah, you gotta.
It's just that.
Double. It's been taking me about 15 minutes. I go to the bus.
Yeah.
The bus order the 20.
I usually, yeah, sorry, yeah. I go to the but like.
Oh,
Oh,
I guess that.
Oh, actually, if the worst got worse since congestion.
So you can basically reduce other numbers.
It used to, I used to like, use the and then
But
like,
when you go take the, just go down, the SGS and the.
bring it up.
Probably run like that.
The boundaries there. Yeah.
okay, but I picked like 25, it doesn't have to be like a perfect.
Yes, try to look better than any number.
Yeah.
If you whatever, when it comes up.
Because I'm right outside.
Tiny little. Everyone's dropping here.
So, yeah.
Oh, and it has like 30 steps, you know.
Okay, I tried to wait, and went out.
Okay.
20 minutes, that's less than. Oh.
That's the advantage.
Two doubles and a single after that.
You can just run it.
And I was like, well, I got off at like second, it was long.
You may take more data to create than you may.
Sure, I love that.
Yeah.
Where'd the line go?
So like not lines.
Yeah.
But,
I'm trying to think this.
Like this is long.
Sorry.
Braggers weren't maximum.
Okay,
That's fine.
If you want the rest of those, yeah, you don't.
I only picked on nature list.
I do only get it.
But it's still out used to.
Oh, I think we talked about this before.
Yeah.
Oh, yeah, that or something.
Yeah, it was the first day or something, so
Yeah.
I've never like.
Server
Yeah,
thing.
we do it. Well, so, but yeah. You can use those.
I saw it, you are also like a server. That's just part of it, like, exactly, but.
Yeah, once
Yeah,
it's
like if they align. Model the picture or something. They have things like that.
Yeah, so I think it's like, it did that like if I didn't. Like it goes down.
Oh, yeah, exactly.
So I had
That's kind of very sometimes.
We know how
I think I just specifically really. I'm sure.
It's straight like, instead of.
It's just very, I don't know, very different now. I was there before.
Oh, my, very.
I know, implementation, like, they're kind of.
Here's not the only all of the. I just saw download all of them that work well. I was like, it's like, oh, it's like as hard as you run these people.
People really didn't expect.
Data, barrel storage, culture, hierarchy.
Since it's not really user friendly, get them.
No, it's like one
I
guy
like.
Which is why
It has to be
I
why.
ended up switching.
Whatever
to
the
techniques.
Yeah.
Cause it was either like, she was kind of just like leaving behind before that, but I was like, I'm not here.
Yeah, so they are.
Yeah, that's why I but like, yeah, so
but
it's like just very
aren't there,
different. She
they
can't
can't
even
be
afford it.
afforded.
Only other one on the floor was air gliders, but no one had surveys out of like, that's not big. So like,
Yeah.
yeah.
Wow.
So it's very different than when I was there. Yeah, but it was like, and I liked it about it.
Really?
Yeah, the data broke up pretty hard. Because there's and it wasn't like I was alone.
Yeah, well, nice, very slow about that.
It's a lot to try.
And yesterday, and I would like to
Yeah,
see that actually.
Other than Pumpkin.
Yeah,
the
so,
vaccine
like, when I was here, like, when I was 160. She gave me a lot of.
Yeah, but if you're lucky, you can still help that too.
Yeah. She could do.
I opted, yeah.
Like, handle it fine. She was like, you can either like go.
You have served.
Honestly, go down, but also if you want to say.
Well,
yeah, you were a postdoc,
maybe they
she basically only had.
Yeah.
Staff and left, that's all. She was like, you can either do photographs or someone at her.
But you can download it, get it going.
She had like a lot of people.
Because you get like a 30-day license.
Took the job.
Yeah. And then you can go in and say, hey, I'm a non-academic, yes, or an academic.
Like I have some.
You can apply for it.
There's 4 or 5.
Yeah.
Imagine it's also concept. Kind of just standard, like, yeah, it was fine.
Yeah, it's sort of a pain like
Yeah.
that, but.
Yeah, I mean, it was really like, it was, she's like.
Yeah.
And she got like, she's.
Yeah. You should.
So like. She, it wasn't
Like
unexpected.
you wanna help you know. Right.
Yeah, no, it's
It's like,
basically like
for
very.
So.
Sure, yeah. Well, tell them I said,
She was there.
You're like bizarre map. Map is interesting.
Yeah.
All
It's like the facilities,
Yeah,
are
but he's-
all the walls are like nice. Yeah, at least they were.
Yeah.
I worked
Yeah,
there
I have
2019,
Yeah.
2021.
Yeah.
And then I had, yeah. And she, her one closed on.
Okay, well, as long as it's.
Oh, so you're good. Sorry. No, you're fine. No, sure. This thing is indestructible. I've put it through enough.
Okay, well, I'll just put it forever.
You have to put your laptop on.
I'm not seeing. Oh, okay. I probably would think so.
Yeah.
I would do that.
Seven.
You did, you match just.
It's all, I don't know.
Yours looks so good. It looks just as good as last time.
Yeah. I don't know. Real life.
Yeah.
Should have known.
Mine's real slow.
Didn't know what was happening.
No,
We don't necessarily.
It's different one, like, progress,
maybe, it's pretty slow, right?
it's very slow.
Cool, yeah, I should
You
do
don't,
that.
If you want to use the network.
I'm just gonna.
Yeah. Yeah, send it.
Right, tap with the smooth sink, the cold water is filtered in the kitchen. Yeah, there's so much, no worries.
They upgraded it.
Yeah.
At one point it wasn't there.
It is nice.
Everyone would like that,
Last I checked, the performance across most networks. is very
You doing? Alright, too.
But it was going to for this purpose, we had it's like that could be it, just sort of some years since that's.
Oh, yeah.
That's a thing that's like radius data, but it's very quick.
But it is pretty interesting.
Very
I'm
well, but small.
just interested in correcting ground truth, you know, like
Yeah.
This specifically, you then, like, that's on there.
if you don't get it right,
You,
you will not just, I think it's subtracting the bits that you got wrong, which you just really.
Yeah.
Right, so that's the key, it's not that. SR, that's just it's the version that wants to be trying theoretically a little better.
Yeah.
You can't really tell. I think because one of the things I've seen with that AI is part of those useful, not rewriting some paraphrasing.
That's like,
They do perform that image processing, it's like some code, some kind of ability to segment it. I have no idea what it is to say. It doesn't have any priority knowledge about life science or graves in steel or whatever else. I don't know. Which is probably just where it should go, but that's not.
Yeah.
Oh, your laptop is not. Okay. And run it, you have Windows, right?
So I'm running.
Yeah, I really feel like some, yeah, one of the issues.
Oh,
Cause
okay.
I thought I'm getting like it's to be a simple.
Which I don't know if
thing,
you
just
ever
simple, but. Yeah.
Right, but
I mean, the difficulty is that
because
we don't normally have.
on Windows, it just goes like you all
No.
install.
So it's
I'll
very
install like
well-
most libraries essentially,
Yeah.
like set up some libraries. And so that's like really more difficult.
But I was thinking if you want to teach.
With different hardware and hardware stuff always massive.
Is,
So
you
if
know,
I
the
could not that, the right sort of like.
Okay, yeah.
You know, like also pieces, trying to detect service are a big thing. But I think fundamentally, it might be detect the field which you use or something.
Well,
Yeah.
that's plenty of statistic I have tried to use.
Yeah, I used to have that would be very low.
Yes, in your case. Do many of can thinking, magic one like features?
So, like, they do, even like, I can get it to segment, but it was
So I mean, I
fill
don't
in
know.
the missing witch. Like, it will,
Dragonfly does that, so the servers, like. are-
like here, it was auto segment, like on a mirror with even out much tracking, like the outer layer.
Yeah.
But I can't get it to make a full circle.
Are you doing like this?
Oh, there's construction, yeah.
It would be great. I'll have a match right now.
It's hardly the difference is that we haven't figured out.
Because I'm assuming that this year, they actually, you know, you got long, thin papers that span,
So,
you know, more than one principle, or at least.
how about it's
Yeah.
and she was complaining that the line people like you do it, like you could stack that to right, go back and use all on way. The context is where they go with one minute, but in fact there is, and that they're doing it, we just said. Maybe, it's not
I've been
very,
using it to
so.
like
like a
five
huge multi.
my grids with EPU, I can't, like, because it's not evenly distributed, like.
Team Tomo Windows is the right one, even if you're doing it manually, we have figured out as discovered, you can actually do single
Windows works great with that sense.
but without selecting operations. Anyone, single shot.
Yeah. Probably I.
Are you running that?
Screenshot.
It's enough of an ass, okay.
Are you running it at med school, or you,
It's so
so you're using documents?
They haven't done a lot of topography there, so it's like a bit
Yeah.
tricky.
Yeah, so you're probably gonna be the most advanced Tomo finding. We
Yeah.
also got Tomo Live on load to them,
Yes,
which have been troublesome to get going, like everything.
someone, Zoltan,
Yeah.
made like the 3D and so we got it
Oh.
up and running, so Tomo Life is working on the three us.
So that's supposed to sort of get you to the point where you can see a Tomo graph it's still collecting. But
Yeah.
also it's sort of not the end of the pipeline, which I learned second day. or whatever.
Yeah.
There's a whole suite of things to do.
Yeah.
Yeah, we should give this to Matt.
Oh, you.
Tomo Live?
No, she has a field that one structure in it, not, numerous. I don't know whether an AI operate on low statistics like that.
Oh, I see. You mean it's a crowded environment, but there's only one?
No, there's like empty and then like one very large tube.
I don't see why it wouldn't work.
I think my issue in finding is like, it's not filling in the wedge to make it a circle.
I see. On the segmentation.
Yeah,
Yeah, it's hard. Sometimes, I mean, I don't know, like the only time I ever close in the missing wedge is with like our vesicles. Sometimes we'll close in like a whole vesicle because it trains well enough to like somehow distinguish the top edge of a vesicle, but it still misses the tops and bottoms of microtubules a lot and things where the missing wedge is.
yeah, I haven't found like, I've only tried icing it and I haven't been able to find parameters that will like, because there's two layers, so it will start joining the two layers together before it like fills in the missing wedge and making an artifact that
Yeah.
I don't want.
Yeah. So is everyone back? I can't remember. I think everyone's here.
No, they're all this way.
All right. This network could train for a while if you wanted it to, and it'll just get a little bit better. By the time you see,
Yeah, unfortunately.
actually, it's not truly asymptotic yet, but like, we're only going to get so much more out of this, and we only have so much time. So
It's like.
Let's-
Try segment the whole tube.
stop this from training.
The performance really makes the train. Yeah.
We'll wait for it to show. All right. I'm going to close this training tab and I'm going to close the deep learning tool. Now, as part of the data that we had just imported before we trained, there is a tomogram.
Yeah.
It's called Cofalactin in vitro tomo. It looks like this. It looks like nothing when you open it on slice 40, but if you scroll down or up to like slice 58, you'll see that. Whoops. If you zoom in on this, you'll see that this is obviously two different filament types. I mean, they're both actin, but this one has cofilament decorating, so you get this like much more twisted looking structure. If we click on that tomogram or select it in the properties tab, we can come over to segment with AI. We can find that cofilin unit that we just trained and hit segment. Hopefully that happened. All right. Now, I know I have one I trained that worked really well. I don't know what this one's gonna do. It's a problem. A lot of times when you like I download a lot of MRCs from or Tomos from the EMDB, and for some reason, some people really like to just put like 1,000 voxel thick tomogram, like onto like be reconstructed in some crazy amount of space, and it's really only like a little bit of biological material in the middle. And it'll take a long time to segment, to crop your tomograms. That's all I'm saying. All right. So it did a pretty spectacular job. Let me see. Maybe these green, the colors are kind of crazy. Let me see if we change the green to, let's go red, and then let's take the background and make it white so that it's higher contrast. That's not the background. I forgot to label these things apparently. So let's go green. Let's go. Let's make this one white. Okay. It's not perfect. Probably could have trained it a little longer, but you'll see that it gets the filaments really well. And it actually starts to pick cofilins off of the outside of these. Now, there's a bunch of junk that it gets, right? Like all of this little like pieces of probably actin polymers and things like that floating around. This is partly what I was talking about earlier with in vitro sets. But if you scroll up and down, you'll see at the air-water interface, there's this layer of just junk. What if you wanted to get rid of that junk? That was what I was going to try to do. Retrain a network. So what we're going to do, let me test and see if this, I still think everyone's going to have their things crash. Let's try this. Actually, you have it open. Right now, you have open in your properties tab an object called cophylactin cropped tomo. Right. And so what we did here is we cropped this out in a region where we had a bunch of, here, in fact, maybe we can turn this on. No. I want to show you the finished product here. Basically, we went through and pushed all of those specs, right? Like these are no longer in this segmentation. We pushed them all into the background and retrained. Now, I thought I had the non-cleaned version, but apparently I don't. So let's try to do this. Yeah. Sorry, I got off track there. Okay, so I'm going to, I don't know if we can zoom in or, let's just right click on the cophylactin in vitro tomo and crop or modify transform, and then go to crop. Now we should have our bounding box, right? Let's see if this works. I'm going to drag it from the top, bottom, left, and right. Down to the center. Now, we want to get the junk as well as our data. So just as a side note, I have tried doing this where I just crop out, say, like a piece of the background. I don't have any of the actin or cophylactin signal in it, and I retrain using just the synthetic data and a piece of nothing but background. And that background itself will override a lot of the network's weights. You have to play around with weighting them. Once you put real and synthetic data together, they balance in ways that are not truly predictable to me yet. But one thing I can predict is that you don't give it some of the real data for all of the classes, you'll probably not get a great network that comes out of here once you've combined all of this data. It'll override your synthetic data. But let's see. So I'm going to try scrolling down to just below this junk. I'm going to say, okay, that's 47. How is that not right? It's not working. Somehow the bounding box is not syncing with that. We may be just out of luck for trying to.
So you could apply the network to the,
Say that again?
apply the network to the already cropped version and hope that the ROI tool.
Oh, that's a good point. That's a good point. Let me do that. Let me try that. So Carson suggested I take my already cropped tomogram, apply the network we just trained to it, so that we can get an ugly cropped version. All right. So that's what we have here. I don't know if you've been able to replicate that. If not, tell me where you got lost and I will back up.
All you did after you ran the network was just crop a piece of it?
So I tried to crop a piece of it, but I can't get the bounding box to behave. And so I have a saved cropped version that we had opened
Oh, okay.
with the data. It's called actin cophylactin cropped tomo. It's right from the middle of that tomogram. It's where I wanted to crop it, but it's not letting me.
I got it.
And I'm just segmenting that to give myself like an ugly version of the segmentation. Now, this just happens to be like a really bad example of trying to do this, because normally, like say it was just actin and cophylactin and we weren't actually trying to segment the little cofilin off of it, I could just remove islands and like get rid of all of these tiny little pieces in one button press. But when I do that, it's also going to get rid of all of my tiny little cofilins class. And so it's not ideal, but let me try. So if I select the segmentation and I select the blue and the orange, let me just see if it crashes before we. Okay. So orange and blue. Well, it didn't crash, but it's a real pain in the ass. All right, see, so if I pick yellow and orange, yellow is this thing and the orange is the background. So if I hold select or not select, shit, it'll let you push all of that into the background.
So will it? Naive question, but like, will it just, why is it switching orange or yellow to orange and not orange to yellow?
Yeah, good point. I tried to say that, but I must not.
I can't do it.
Control does one and shift does the other, depending on the order in which you select. Like, the cursor will be the color of what you.
Okay,
If you click on one of these classes.
I'm scared it's gonna crash it,
Oh,
because it kept crashing it. That's what I was just asking.
I forgot. If you click on one class
Mhm.
and then you control click on another class,
Mhm.
it'll actually select both of them. You can see
Yeah.
this is A and B.
Mhm.
And then if you toggle between control and shift,
Mhm.
and you'll see that the color changes between like the two classes that you've selected.
Okay,
And it will go to whatever color and all it will do is swap those two classes.
okay.
Now,
So like if you went over blue right now, it wouldn't do anything.
wouldn't do anything.
Okay.
Good point, though. There's no reason really to do what I'm doing. You could just push it all into the background by selecting background,
Okay.
holding control and just pushing it.
Clicking stuff.
Yeah.
Okay.
Now, I'm gonna get this a little bigger. I'm gonna try not to erase, probably already erased some filament. Let's see. See, you have to be careful. Otherwise you like have your 3D brush and it just erases
Yeah.
something from down below. So, for the sake of time and getting through more interesting things, how about we just practice setting up training? Let's say that we went through this and we pushed all of these little bits into the background, but we kept and that's what I have right here. If you look, you actually have that segmentation. It's called cophylactin cropped ground. And this is the one that has already been cleaned up. So I've already gone through and passed everything to the back. So let's pretend that we did that. It's not real fun to do, so it's all right that you missed it. But how do you set up training with both of these now? So what we tend to do is give it all of the training data that it had previously plus the new data. And I like to just completely retrain the network for some reason, but there's no reason why you couldn't just continue training the network you've already trained. But let me show you how to do that real quick. If you go to the deep learning tool under artificial intelligence, you will find, well, first of all, in fact, let's just do this. Click on your version of the cofill in UNet. And then on the right-hand side, there's a button that says duplicate. Just duplicate that. So now you have another version of that trained network. I'm going to just rename it cofill in UNet clean or something so that you know which one it is. And with it selected, we're going to go to the training. And we're going to do basically the same thing we've done. We're going to grab the actin, cophylactin split tomo. That is the fake. I should have written synthetic on there so that you knew it was a synthetic tomogram. And we're going to give it that multi-ROY from 4 ROYs that we generated earlier. Now we're going to press this plus button to add another data set to the inputs. And you're just going to grab that cophylactin cropped tomo.
Where was the plus button to add any data set?
It's right here.
Oh, okay.
Yeah. And then we're going to grab cophylactin cropped ground as the output. And that's the cleaned up version. Now, we probably only have to run this for like 10 epochs, and I bet it'll clean up. And so if you just go into the training, or if you just hit train after setting up those inputs, it's just going to jump right into training and it's going to retrain. And since we're giving it all of the old data, all the synthetic data plus the new real data. And we're really just trying to make it ignore things in the background. I've found that you really don't have to retrain it that long. And obviously it's slower because there's more patches, but I think if we just let that run for like 10 epochs, it will probably ignore everything other than the action. Anyone totally confused?
Need to have a reminder.
Yeah.
Can you remind me how you got the multi-port ROI for the synthetic data set? Did you do that manually?
Yes. You fortunately, they're generating something. The synthetic data atlas that came out of, I don't know if you
Does it
remember that.
come with a?
So-
master authority?
Oh, it's already trained. So. The simulator spits out.
Okay,
Then you just import that into Dragonfly. You extract all of the different classes and regions, and then you combine them.
okay. So if you were starting from your own data set, you, those like ranges of interest, all the classes, you would have to set, you'd have to do the drawing tool.
Yeah, exactly.
Okay, got it.
Exactly.
And then even if you manually set all the different classes and draw it, you can combine those still as a multi-Roy, like you
Yes.
have, okay.
Yes. Absolutely. And just like, maybe we could come up with some way to easily contact each other, maybe email. Email me if you guys have any trouble. I'm gonna share with you, I have like a finished tutorial that I've given to lots of people that I was trying to make better before this. I'm gonna send you the old one just so that you have something that'll walk you through installing CTS, running it, generating synthetic data sets, and then getting them all into Dragonfly. This is step by step for all of that. And since you've done this, it'll probably be really easy to follow. But it has all of those things in there. So you're not going to see this like, this is an already trained network and it's already seen a lot of this data. So it's actually not going to like drop really far. In fact, it'll barely drop at all. All right. And we'll just watch it go for a few more epochs and then we'll see what we can get away with. You let yours continue to run. I'm going to stop mine and see after 5 epochs what it looks like. Let's see. Oh, I haven't been doing it, but just so you know, next to segment full data set, there's a little button called preview. And that'll literally just segment the one image that's in your display. And so if you just want to see, like check and see like how that model works, you can just press that button. Won't go through them all. No, it's not perfect for sure. It's not good at all, actually. Okay, let it go. Let me show you. I did this at home with this exact same data set. And actually I can cleaned it up.
Usually you iterate this a few times. Drop another section, clean it up,
So,
add more training.
I mean, apparently 5 iterations is not enough. Normally, 1 iteration like this would clean up most of this junk, for sure. It depends on what you're trying to do. One of the next things we'll do is open up the data from neural seg, which is like blocks of data that we generated. And there it was very iterative, right? Like we would have to go we would add new data, because what happens is you make this network work, and then you apply it to some other data, and it doesn't work really well there. Right? So here we go. This is the cleaned up network. Hopefully you can appreciate all those little spots are just gone. It is still finding some of the carbon. We could add some carbon to our training set and really hammer that out, but like we added a fiducial fold, and so like it's missing all of the fiducials as well now too, or it's ignoring them. But that's the basic premise of retraining. You're right though, in that like we will retrain and then we'll be like, oh, that looks really good, and we'll go to another tomogram that it used to work well on and it doesn't work so well anymore. And so we'll be like, okay, well, we definitely need some of that data, and so we'll pull it in. And there does seem to be some, I hope, and there does seem to be some threshold at which, you just have enough data and it's kind of good at seeing most things. But if you run into stuff that it doesn't work well on, there's no reason why you can't crop a piece out, concatenate it to our neural seg data, retrain the network, and just have your own version of it. All right. So that's using synthetic data alone, train a network to segment in vitro data. It works really well for this kind of stuff, typically. If you have some relatively pure thing in ice and you need to like quantify something about them, it's not that hard. But let's close everything related to cofill in there, except maybe the leading edge. Leave that there because we use that tomogram a lot. So let's take a look at other things I have. I have synthetic cytoplasm, so we can like train. We don't even have to train. I have networks trained, but I can show you how I would train it. We have the neural seg data, and then I have some data for training a regression network. We still have like an hour and 10 minutes, so as long as we don't like belabor the point on everyone, I think we can probably get through it. Okay. So let me show you this. So how do you get into a cell with nothing but synthetic data, right? Oh, I forget that I'm not here. All right. What I'm going to do is we're going to open up training data called training data neuroskeleton. And then what I'm going to do is I'm going to click on and open up one of these. So this is some synthetic, what I would call synthetic cytoplasm. Got membranes and microtubules and a bunch of things just jammed in there. Whoops, no, that works. Now, basically in CTS, even though there's like 50 different molecular species in this one tomogram, Carson has written it so that I can designate all of the ones that I want to be in the background class prior to generating the data set. And so here I was able to just like say, give me all of the microtubules and actin and cophylactin. Right, so these red is cophylactin, green is actin, and blue is microtubule. Now, if you look at it closely, this particular data set is kind of funny. one of the microtubule intraluminal proteins segments is red. And that's because there was some weird glitch going on with my PDP when I made this data set. Just ignore it. But we have these two data sets. One of them is real heavy with microtubules and one of them is heavy with actin. I was just trying to get a balance of the two sets of cytoskeletal proteins. Okay. Now, I'll show you, well, really quickly. I mean, there's nothing different about this. You just say, give me a new thing. We have how many classes? 4 classes. You don't have to make this network. It's just like the last one in the sense that we're just going to give it 2 training sets, right? So everything's going to be the same as we did before, but we're going to say, go to training. And just like on the last one, we're going to tell it, give us neuroskeleton actin tomo. Neuroskeleton actin ground. So we're going to pair those. And then we're going to just hit plus and get neuroskeleton microtubule tomo and microtubule ground. I don't think you guys need to see me hit train, but you would train this just like we did the rest of them. And you'd see the learning curve. And then at the end, you would test to see that it even works. So like, let's take this data set. Oh, you know what? You guys actually have all these networks on your computers. I've been meaning to, I forgot to tell you this. Let's do this real quick. If you go into Deep Learning Tool, on the right-hand side, there's an Import Zip button. If you click that, you can find your way to the models folder within the Dragonfly data folder that I have. Now, there's like 9 different models in there. You don't need to import all of them. You can only import one at a time, unfortunately. But we're going to get this one called Neuroskeleton Sim. And just hit open. So that imports that train network into the system for us. And I'm going to pick it, or you can select it too. You should have a network in your segmentation like model drop down now called Neuroskeleton Sim. Does everyone see that? All right. And I'm just going to hit segment. It's a good idea to look at your training data and just make sure that it actually like functions on the data that it knows. But you'll see, it actually learn to find that central bit. But it doesn't do it in real data. It like specifically knows how to find this one. So it's pretty good. Now, all you have to do to infer that is we're going to open up open up leading edge. And we're going to segment off our full data set. And so this is a network that's never seen any real CryoET data at all. It's never seen an actual cell, but it's seen this like abstract kind of version of a cell. It works. So it's not perfect, but you didn't have to do, you had to do almost nothing to get this network other than, well, that's not totally true. Go ahead. It finds the microtubules quite well. It's separating actin and coprolactin. Now it's not perfect, right? There's obviously little bits right here and there, 3 mixed in that may or may not be real. I don't know. Getting the tip of this microtubule is actin. But if you were going to train a network to try to find these objects, I would suggest doing this first. segmenting your data set, cropping out whatever you want, fixing the little imperfections that it has, and then retraining your network. It's way more fun than hand segmenting everything. Any questions about that?
You need to start with the synthetic data.
I start with the synthetic data. Yeah, start with synthetic data and bootstrap your way into getting like an initial model. And then refine that model.
Augment it with real.
All right. So that's that's neuroskeleton. It's just seen 3 different types of cytoskeletal feature. And it works as like an initial model for sort of getting things going. Oops. So I keep hitting the wrong button. So let's do this. Let's import another training set. So if you go to the New York NSYC data, training data, there's one called neural seg training data. Yes. All right. So neural seg. I'm going to walk you through this data, just so you can see what it looks like. So this is 10 synthetic tomograms that are stacked together. You can see it's like 500 voxels thick, and some of them are very low signal. Some of them are much higher signal. They're slightly different pixel sizes. They have different mixtures and densities of components within them. And we concatenated them all. And we have the ground truth. I even put some fiducial markers in here. You can see them. These are simulated old fiducials that you can add in CTS. I forgot to mention that. But I'm telling it to ignore it. Now, did that work? You know, kind of. We still had to put some real data in to distract it. Now, the other block of data in there is called concatenated real tomo. Now this is, I don't know how many tomograms, but maybe 10 different tomograms that we cropped chunks out of. And if you turn on the real ground, you'll see the segmentations of those different cellular compartments. And we did this in an iterative fashion. We started with just a small amount of real data from neurons and then moved towards including non-neuronal cells like bacteria and things like that. We did have to hand segment a lot of these because it didn't know how to get mitochondria, right? There's nothing in our synthetic data that looks like a mitochondria. So we had to hand segment these portions just to like make it work. What you'll also see in here, see there's a bacterium right there. All right. What you'll also see is the background stuff. So this is just distractor data, right? So this is ice contamination or whatever it is on the surface. Maybe it's ethane, I don't know. But we just put it into the background. Same thing here with like the surface of this carbon. Boy, surfaces of carbon really like to, it's segmented things. If you have real signal there, you should try to keep it in your training. But this was a mess until we cleaned it up. And anyways, so it's more training, right? More training. This one would take a while to train, right? Like overnight to do a really good job. Maybe only 6 hours, but it still takes time. Now, what does it do? You guys have all of this. So go to the deep learning tool go back to that import zip. And you should be able to go into the models folder and find one called neural seg local. If you open that, then we can play around with it. I mean, it's more segmentation. You guys need to see any more segmentation?
What's it called again?
Neural seg local. You don't have that?
Yeah, it's.
Okay. All right. For fun, grab the leading edge Tomo and hit segment all. This is a 7-class network that it started with neurons. So we basically are looking at everything that was easy to see in neurons. Actin, coprolactin, microtubules, ribosomes, TRIC, membranes, all the big stuff.
I think I missed it. What are you doing with the leading edge?
Oh,
How did you run it? What'd you run it through?
sorry. I did the wrong neural network. What was that again?
When you were saying to do something to the leading edge tomogram, I just didn't catch.
Yeah, so select the leading edge. In the segmentation models, change to neural seg local.
Oh, okay.
Sorry, I didn't say that part. I forgot to do that myself.
Where did you get the neuro seg local from?
Yeah.
I think that's what I was.
Go to, I see.
I
Deep
opened up the
learning,
data, but not the.
deep learning tools, so artificial
Oh.
intelligence. Deep learning. Yeah. Import,
Oh, okay. So-
go. Models.
Thank you.
Yeah, sorry about that.
That's okay. I was opening the neural seg data.
I see.
Okay.
And whatever, the point of this is just this network finds more things. It's better. It's just trained iteratively on a fair amount of data. But just to give you a sense of like what, I still think it's not that great a model. Like I say in the paper that someone's going to make something way better soon. But as a first pass of making like a generalized CryoET model, it's pretty fun. And we may be the ones that make a better one. I just mean like it's so easy to like run this on more tomograms, see where it doesn't do well, import that data, retrain. I mean, like, so making it better is not hard. Someone will do it. And so this one, obviously, so let's go to a 3D view. We'll just look at this in 3 dimensions. So if you right click on the thing and hit the 3D button, and turn off everything that isn't the segmentation, and then open the segmentation. Oh. Right, so it's distinguishing between different active filaments. These are TRIC molecules right here in purple, ribosomes, and everything. So the exciting thing about this network is that you can open up other tomograms and run it on them. So for instance, if I go into the data and I say, like, let's go back to, I think it's this one. So this is one that, oh man, come on. XY. Yeah. All right. Of course it's going to do all right here. That looks like a neuron. It's pretty high signal. There's no reason why it wouldn't do well. In fact, I'll just preview it so we don't have to see the whole, or take forever to see the whole thing. You can do that in 3 dimensions, and you can get yourself a segmentation. Okay. just as a example, this is not a perfect tomogram. This is a very thick tomogram. This is what a lot of tomograms end up looking like. I'm showing you all of this on really high contrast data, but this is from the central domain of a neuronal growth cone. And if you scroll through it, I mean, obviously there's stuff there, but it's significantly lower signal. And just to show you the limitations, it does all right, but this is a tomogram it's never seen, and it's actually significantly lower signal than it probably wants. But oh, that's going to take forever.
You said with neuroseg, it's kind of random whether or not it likes the noise inputs.
Not with neural seg specifically, just
Okay,
any
general.
network I've used. We can actually do that. In fact, next we should play around with some denoising and try segmenting it and see what happens. When I first started doing it, I thought, oh, this is going to be amazing. Like once I denoise this, like the segmentation is just going to be so easy. It hasn't been quite like that.
Is part of it just because noise sometimes gets like
I don't know.
The contrast is radically different.
Yeah.
Dragonfly gives like the calibration process even under is and so when you change the signal densities by orders of magnitude, so you can train segmentation model on the data.
okay.
But if you train it on noisy like data,
That is fun.
This isn't even going to be that cool to see. I didn't know that it's probably, it's a thick tomogram, so it's like taking forever to break into patches. But that's Alistair was talking about signs of progress, like real measurable signs of like being able to get subtomogram averages in an afternoon. I feel like getting a segmentation in a matter of minutes is pretty good. But you'll see, right? So it does an okay job. It actually gets a lot of the microtubules and hold on. And it ignores a lot of things. It gets ribosomes, much of the membrane. Now that mitochondrion in the middle, which has like a matrix like it's never seen before, it's definitely like struggling there. It's struggling with a number of things. It's not like perfect. But it didn't take me any time. So we could even try denoising it and seeing what happens. So let's talk denoising for a minute. Unless anyone, I guess, no, let's just talk denoising. I keep hitting that button. All right. So if you go back in and go into training data, there's something called denoise training data. And this will be at least a little bit different. We can look at like how the ground truths compare. But so if you open like, all right, these are the same tomograms I showed you earlier from the neuroskeleton segmentation thing that we did with simulated data, except instead of having a ground truth that is a segmentation, we have a ground truth that is like a noiseless tomogram. So you have both of these tomograms there. Setting up training is very similar to everything else. You go into artificial intelligence, deep learning tool, new, UNet. All you're going to do really is change this from segmentation to regression. And I'm going to make it 11 slices so that it's a 2.5D network. We're going to call this regress. And we're going to generate it. So it's as simple as that.
And the model type's different. Why?
So we want to get. It's basically the last layer of the output layer of the neural network chain. From one that, I'm gonna mess this up, it's been a while since I thought about it. Semantic segmentation, right? That's like the output needs to be some probability that it is that object or this other object. And so the output is not a probability, it's literally like, is it ribosome or is it making decisions about each voxel? And it's trying to say like, is that voxel a ribosome, a microtubule, or whatever? And it's just gonna spit out microtubule. And you need a special, they call it a soft max layer at the end of your neural net for like doing this. And it's just, so it changes the way that it outputs the final information from the neural net. In the segmentation, like I said, it's going to tell you, it's just going to tell you what class it thinks it is. In regression, it's going to make a calculation about, I guess regression is what it's like.
Is the output of this a denoised image?
Yeah.
So it has to have every voxel, right?
Well, it does every voxel,
Not
but it's
segmenting subset of voxels.
not segmenting anything.
They won't set them up for prediction.
Yeah.
It's just one of them's predicting class identification, and the other is predicting a voxel value without.
Yeah, exactly. It's like it spits out a continuous value for what the intensity would be at that pixel. All right. Now, we've already done this. Nothing's different about, other than changing that regression kind of output. You're going to come in and say SimTomo1 noise. So I'm going to tell it our input is the noisy tomogram, and our output is the prior version. So it's the same version of it, it's just got no noise. And then you're going to hit plus to add a data set, and you're going to give it the other one, Tomo2 noise and Tomo2 prior. And if you really want to train this, I would change it to 128.
So you can use the synthetic data to train the denoising model?
That's all I do.
Okay, and then you can use that denoising model on your real data.
Yes.
Because this noise is synthetic noise, right?
Yeah.
It's been generated by the simulation.
Yeah.
And then turned it on as one of the options.
Noise certainly came out of the reconstruction. Now, one thing I'll point out, so for regression, the loss function will generally use mean squared error as the loss function. But I have gone through almost every one of these and looked at how it changes. I really like this one called ORS mixed gradient loss. I kind of know what it's doing. I don't know how their exact implementation, but it's multiple loss functions that are kind of optimizing for different things and then being combined into like a final output to try to decide whether it's doing better or not. But I have this network trained. We don't need to train it. We can just apply it. I just thought I'd hit train for the heck of it. We'll stop it. Now, let's do
the denoise button. I missed that first.
We didn't denoise yet.
Okay. Well, how did you do things to generate the denoise? Anything, that's the button.
No,
Okay.
it's not being covered here, but we can talk about it. Sure. So I'm happy to do it. I can show you exactly how to do it. This is all out of CTS. So we're in MATLAB.
Yeah.
We're running our program.
Yeah.
We generate a tomogram that's noisy.
I see.
And then we change the parameters and we say, we'll make another copy. But we don't want any noise.
Yeah.
It's not that we ask for no noise, it's just that we turn off the detector essentially. We make it kind of a perfect detector. And we, instead of going plus or minus 60 degrees, we go plus or minus 90, so that it's like a full tilt. And so that's what our ground truth is. And in fact, good question. We can maybe go through generating some of that. We don't do it in Dragonfly though.
You'll have to.
Yeah, well, we'll see how much We have some time.
If you have time later, I definitely want to see.
Okay. All right. So, in fact, we'll just get to that after this. But let's look at this, right? So here's the synthetic noisy data. In order to denoise this, you have to go to the main tab. So we've been doing everything on the segment tab, but on the main tab, there is a thing called, where is it? Called filter with AI. It looks a lot like the segment with AI thing on the other tab. You literally just select your tomogram that you want to denoise. You select your model. Right here, I have this. You don't have the model yet. You have to import it. So I keep forgetting that we didn't do that. So quickly go into the deep learning tool. Hit import zip. Go back to the models folder and you'll find one called walkthrough regression unit. These all have interesting names. We're supposed to go through with the walkthrough that I was going to give you, but I don't have it yet. All right. So if you now apply that model to that synthetic data set, it'll go pretty quick because it's pretty small. Oh, Dragonfly does some really weird things occasionally. See how it came out just all white? It's not all white. It just looks all white. If you go and get the, oh, come on, where is it? Under window leveling, you select this area tool and you click on it. You can like drag this and it'll like show. It only does that when I denoise synthetic data for some reason. I don't know why. But
Sorry, what did you click your denominator like?
this
Oh, okay.
is the area contrasting tool.
Okay.
And I just dragged it over this and like let go. I don't know if that makes sense, but if it's not working, I'll come and show you how to do
It
it.
almost just looks like a display bar, right? It just says that it's white. The data's there.
Yeah. And so if you look at this, so like let's turn on, so we have this is this, and I'm switching right now between the denoised and the original ground truth. You can see a slight difference. The ground truth is actually a little bit noisier. It actually seems to denoise more. But it actually does certainly does a good job at making it look like the synthetic tomogram. Now, the idea that this would do anything useful for a real tomogram is a little bit crazy. But if you select leading edge and you filter that, all right. So see, it does something crazy here too. It makes it look insane. But same thing, if you just select it and drag your contrasting tool, it will bring it back. Now, I mean, I don't know what to say about the denoising other than it works. Let's run, for instance, we'll take the inference. If you look usually when you go to infer to one of your denoise tomograms, you want to check the calibration because something weird happens during the denoising and your foreground often gets moved over away from the peak. And so I'll just reset that and hit calibrate. And then we'll run some segmentation on it. Let's see what the hell happens. Although this one was working really well beforehand, so it's not really a fair test, but if it sucks, then at least it says something. I mean, it doesn't look bad, but I don't know that it looks better. Let's see. In fact, it looks like it missed a lot of membrane or more membrane than normal. So, yeah, we're still working out. And see, look what happened. These are not ribosomes. These are trick, but now it's finding them as ribosomes. Now, we could train a network that would be very good at segmenting denoise data, but it doesn't guarantee. Denoising, in my experience, does not guarantee, at least not with our regression networks. I don't know what would happen with a gentler noise to noise. It might actually help quite a bit. So
It does.
yeah,
If you do a very gentle regression, also reliably help all of them. But the network here is a kick in the face, so.
so let me see. I'm going to open this one called bacteria. This is a tomogram it's never seen. It saw it for segmentation, but not the other network saw it, but not our denoising network, right? Come on. Okay, I already cropped it. This is something it's never seen. It never saw any bacterial proteins. It never saw anything prokaryotic. But not segment, denoise. And so I think, if we have an advantage, it's certainly that it's probably more general than a lot of the other denoising networks. I have not done a lot of CryoCare or even ISONet. I've done a little bit of ISONet, but it seems like you have to train new models fairly frequently to make it work on your data set. Or are you able to train like a generalized CryoCare model that just works for everything? Does anyone use CryoCare? I don't. I just wonder.
ISONet, you do it in batches.
Like you would have a bunch of tomograms that you would train on all at once?
It's like you give it a batch that you train with, and then if you want, you get more.
Okay.
From like a similar setting.
You just retrain like the network?
I think it, like, after it trains, you can then, it will train it with a subset of like 10, and then it'll spit out a denoise of those,
Mhm.
and then you can also get more new
Yeah,
ones, and
yeah.
it'll spit those out.
I know it will. I just wonder how good it is at it.
For me, they're like tomograms I collected in the same session.
I bet if they're in the same session, it would probably do all right, yeah. This is this is a big tomogram for some, so. All right, so that looks crazy. Oops, wrong. But, so for instance, One of the things it's never seen, let me find it. Well, it's never seen any of this, but for instance, you see these two star-shaped objects right in the middle? Those are type 6 secretion systems, like the injection apparatus. It's certainly never seen anything like it or anything close. Well, maybe a microtube. But it's never seen that. And you see this a lot with these networks where like I try to figure out where it's hallucinating, but it does a really good job of preserving structure for the most part. Now, how do we generate that ground truth? Let's see about that.
So you were saying if you run that through neural seg or something, it'll make a class that detects those stars?
No, what I'm saying is we denoised it with we denoised that real tomogram with a network that was trained on all synthetic data.
Oh, I see.
It's never seen anything like that star,
Okay.
but yet it doesn't erase it. It doesn't modify it as far as I can tell. And you see this a lot. As I was just trying to, you definitely want to like look at your data and make sure that it's not just, it's like anything that comes out of GPT, you want to like give it a once over.
Mhm.
Same thing here. All right. What I was going to do, I figure, let me just show you real quick what CTS is like. It runs on any platform as long as you have MATLAB installed, so that's kind of nice. MATLAB is easy to install, so that's kind of nice. I have a thing for like commercially available software. My brothers are both software engineers, and open source software, I love it. I use it all the time, but it's a pain, right? And you need for segmentation some like very specific kinds of tools. And that's why I like Dragonfly. I'm not going to code like all of the kinds of tools that exist in Dragonfly. What is taking this so long to launch? It's like my laptop is mad or something. I've never seen this take more than 10 seconds. All right, so. Let me just set up my environment a little bit. It's kind of crazy right now. Here we go. Okay. So if you have CTS installed and you have MATLAB running, you can get away with just typing CTS GUI, and it'll open up a little GUI. It should. This is being very slow. All right. So this is what it looks like. There's two tabs, model and simulate. In model, you can pick your pixel size. So let's just pick 12. Volume dimensions. I really like, somehow we got on 400 by 400 by 50 and like everything's that size for me now. But particle density, it's the cutoff, right? You're going to place particles for this number of iterations. And if it hits an occupancy of this fraction, it will stop. So you can put a cutoff there. 0.4 is pretty high, and so it's good for most things. Now, number of layers. Number of layers is like how many times are you going to run this 1,000 iteration placement, right? So say we have ribosomes and trick, and we want to place both of them. You know, we could have 2 layers, one of ribosomes, and then we could come in and place trick after it. So you would say, hey, give me 2 layers. And if you wanted different numbers on each layer, you would say, give me 200 on the first layer iterations and 1,000 on the second one. Most of this stuff in here, these are like little things you can turn on and off for making like, well, membranes are kind of important. We use those quite a bit. But
What does vesicle number mean? Like, do you tell it how many vesicles you want to put in?
so it's not completely like that. It is the higher the number, the more the vesicles you're going to get for
Okay.
sure. But it's not like a complete. Is it a linear relationship,
It's the
Carson?
number that are intended to be placed.
Oh, okay.
Some of them don't make it because if they're overlapping with something, or they're the first thing that gets placed, just so you know, like if you ever turn membranes on, it's the first thing that gets placed,
Okay.
so that it's like an empty, or is that wrong, Carson?
That's correct.
Okay,
They gotta be, if they weren't placed first, they wouldn't get placed at all.
yeah. We can get into that. But for now, the other thing worth considering really for sure is this constraints. I almost 100% of the time I use what we call sides. And that's like, it's really the top and bottom of your volume become constraints. And so nothing can stick out of it. And so if you want your actin filaments to land laying like, you know, horizontally, you turn on that and it'll force them to sort of fall within that. Or it will only keep them if they fall in that range. Now, we're going to import layers. Boy, this is being really slow. All right. I can give you all of this. It's in my tutorial. There's a link to this whole data set. So when I send this tutorial out, you'll be able to just download all these PDBs. Now, I have 4 different layers that I usually use. The first one is all membrane proteins. Second one's like cytoskeleton and really large things. So like, for instance, let's say we want to put actin in there. And see how it says actin long.bundle.mat? Well, let me get rid of that. I'll use the PDB. MAT is a MATLAB file that contains all the same information. Carson has it generate a MAT file. You can use them. They're actually faster for in and out, like reading in and out. But they have all the same atomic coordinates as the PDB. The first time you run it, you have to have the PDB. So we add that layer, and then it says, well, what do you want on the second layer? And I'm going to say, okay, well, I'm going to go in and find CAM kinase 2. Let's get routed. CAM kinase 2. And you see how this one says cytosol. So this is CK2, that's the PDB number, and it says .cytosol.cif. CTS has a number of like tags you can put into the PDB so that as it's passing through and being placed, it's handled differently. So if you put cytosol and you had membrane vesicles, it will restrict their placement to outside of the vesicles. And you can put the word vesicle in there, is that true? And it'll only put them inside the vesicle. And so you can make like really the modeling side of things is maybe one of the more powerful parts of CTS actually, because there's a fair amount of freedom there. But okay, we have now imported those 2 PDBs. You literally go back to here and you say generate model. And you'll see that it's attempting 200 placements. It's showing you what iteration it's on, and it's just running. All right, it placed those. It's running to the next layer. Place the CAM kinase 2 particles. It's generating vitreous ice, and it's done. So what do you have now? You have a model. Let me show you what it looks like. Right. So here's the model that you get out of that first part. A bunch of actin filaments with a ton of campanics too, sort of stuck in there. And you can see the vitreous ice sort of within and around the particles. Now you have to hand that model, you go to the simulate tab and you say, okay, well, what model do you want to simulate? And so we're going to open that model. And then all you have to do is tell it what parameters you want, right? So by default, it's plus or minus 60 with a 2-degree tilt, 5 microns defocus with a 300 kV machine, total dose 100, and we have the radiation damage set to 1. I'll just hit, and it's also set currently to a dose symmetric tilt series. So you can, I don't know how much it matters, but you can like do this in any way you want, if that's really how you collected your data. And so then I'll tell it to generate your files. It's gonna, what is it doing? Carson.
If you tell it the wrong dose, will it obliterate the sample or not give you very much info?
Yeah, well, yeah. I mean, it's not, it won't look exactly like the microscope, but it'll obliterate it.
It won't give you bubbles.
It doesn't make bubbles.
The radiation damage is the one place where there's actually a source of Gaussian noise that has to be applied externally. But that Gaussian noise will quickly.
Arrays have incompatible sizes. Arrays have incompatible sizes. Does that make any sense, Carson?
Yeah.
Yeah. I just ran this the other day, so like it's really weird. Okay. What's that?
Did you do dosimetry the other day?
Yeah, I do. Let's see. It's probably gonna still get mad. Did it do nothing? What did it just do?
That's okay.
Okay.
If you did some fractions, it went to.
Man, it ran for some reason. All right. So you'll have now, if you go back to that same folder where your models were, there's a folder that tells you these are your outputs. So I'm going to just open all of these outputs. You're going to see that you first have the model. This was the same model, but it's been inverted so that it will look more like CryoEM. You have a tilt series. So here's the projected tilts. You will have a noisy projected tilts. And then you'll have, what is this? Oh, that's the radiation one. Okay. And then you'll have the CTF. All right, let me auto this for you. It doesn't look great. It always looks kind of like real data. Very low contrast, but then you'll have this tomogram that gets spit out. And you can control all the defocus and whatnot. But you also get this map. This is the ground truth that you can import into Dragonfly with it and sort of extract the regions of interest in. All right. So I can do more with CTS. Not sure what else you'd like to see.
For creating the denoise, I think basically you already.
Oh, yeah. Sorry. Good point, dude.
You just make the settings impossibly good. Yeah, we'll give you baby.
I forgot your original question. So how do you create the ground truth for the denoising, right? So we just created the noisy version. I come back. Now, iMod has this crazy thing in it where if you tell it to tilt plus or minus 90 degrees, it crashes. And so I have to tell it plus or minus 89.
Crashes for a good reason. 5x0 errors, that's all.
And then what I'll do is on defocus, I'll set this to 0. On dose, I'll set it to 0.
Okay.
0 is like a special number on dose. It means like infinite dose,
Okay.
like perfect detector, no problems with it.
Okay.
And then what I would do is, Carson conveniently wrote in the suffix thing. So if you just write us what you want in the suffix, like I'll write prior so that I know that that's the, for ideal. And what I'll do is I'll turn off the radiation damage. I didn't mean, oh wait, if dose is 0, it won't radiation damage, right? Yeah.
On the, like a technical level, if you have the 0 dose thing, that means that there's absolutely no loss of electrons, effectively an infinite dose, and that will give you crazily good images with insane signal. That's the really hard equalizing.
Yeah.
That will prevent you from like doing anything else with that data. You won't be able to segment it with something trained on normal looking data, but you can have a much less harsh regression derising. You just have a high dose rather than a dose. And you have some radiation damage, but not too much.
I think this is gonna, I think this isn't gonna work actually, because since you put the phase plates into the simulator, I have to induce a phase shift to get the kind of perfect contrast that I need. So I have to do it from the command line. I have not updated our graphical interface
Oh, okay.
to integrate his newest edition of a phase plate.
Okay.
So I think what's going to happen when I open this is it's going to look bad. Or like, let me see. If not, I'll just go to the command line and show you what I do. Date modified. See, but now we have this folder called ideal. So that contains your tomogram. Yeah, let's see what this looks like. Oh man, that looks ridiculous. What happened there, Carson? I did something wrong. It's my GUI. It's not CTS. I promise you that. Let's go to the command line. I'll show you how easy it is to run from the command line. So we RAMs. Yeah, all right. So this command line right here will establish all of the parameters, like the defocus. They have defaults. You can just run this command without telling it much of anything, and it'll just put all the defaults in for you. But if you want to control them, you have to do it. Okay. And then it's going to ask you, what model are you trying to generate a simulation of? And you come in and you tell it this model, and then it runs. I think it's already done. Sorry to make you like watch me navigate my. We're going to open up the original tomogram and the prior one. All right. So now you have the noisy version and this, I don't know what version. I mean, it's what we call ground truth, but.
Okay.
And those are what you bring into Dragonfly.
Okay.
And you give it this noisy one as the input, and this is the output.
Gotcha.
Yeah.
Thanks.
But you can do other things. Like, for instance, I gave it no defocus here, but in reality, your data has some defocus. And if you like match your defocus, or even just like kind of leave a little bit of defocus in the ground truth, like half a micron, some people prefer that like look. It seems maybe like a less of a stretch. Like, but so you can pick and choose ground truth in a sense, however you see fit. All right. So I think we covered virtually everything that I wanted to show you. I mean, the big thing left to do after this, like when you have segmentations, is what do you do with them afterwards? I mean, one thing is to just put them in your paper and they're really pretty and they look nice. But the next part of our adventure is to try to do something meaningful with that data. And Dragonfly has tools for extracting things like coordinates, centroid coordinates of individual particles. And so you can integrate Dragonfly segmentations into like a particle picking pipeline. We've done that for sure. A little bit of a pain when you, but this is probably true of all particle picking. Like particles are too close together. It just, they seem to stick together and you get these weird clusters of particles, but there are ways to use like watershed stuff to try to, inside Dragonfly, to try to extract the central coordinates of all those particles. There is no, I keep pounding them about it. There is no like cylinder correlation kind of central line extraction on the filaments like Amira has. And one of the things, I don't know if has anyone ever used that cylinder correlation in Amira? I did a lot when I was in my postdoc. So one of the nice things about segmenting different, like you can generate segmentations, right? You can split the segmentations apart. So you can say, well, these filaments are all cophylactin and these are actin. And you can have the cylinder correlation work directly on the segmentations instead of on the homogram itself. And so if you want to extract subsets and get all of that angular kind of information, Amira actually has like the best tool for that right now. Is there anything else that we could cover or I could show you, answer? I'm not in a hurry to get out of here.
So if we want to build our models, like for example, the material, so how should we generate the initial model from if we need to add a building block?
So let me show you what we did. Synthetic cytoplasm, layer 2. We have this MIP assembly. Oh, that's a dot map. Okay. We've been using relatively short segments of microtubules, maybe what, 30 or 40 nanometers long, maybe kind of 40, 50, maybe. Yeah, whatever. Just open camera. This is what we've been using for everything right here. So I can't remember. Oh, Carson probably had to take, this is probably the unit, right? This got like just repeated multiple times. So I don't know how long that is, to be honest, but if I had to guess, it's probably between 50 and 100 nanometers. But there's no reason why we used only that. It just turned out that it didn't seem like we needed anything longer. And so we haven't made anything longer.
I definitely want to do some landline stuff. There's a filament generator part of the model. It's partially supported. And that will allow you to place like actual helical microtubules and other filaments at whatever length it fits.
Yeah, I didn't really go over it. There's this filaments checkbox here. And if you check that at the end of importing, it's going to ask you on the final PDB import, it's going to ask you for, what, like basically a monomer of the filament, right? And so you hand it like a monomer. And how does it know the helical? It just happened, just based on the name of the file, it knows.
Yeah, there's sort of like a ref function that you need to input that information, to eventually very long numbers.
Yeah.
You use CPF to generate these files from a monomer subunit.
But here, let me show you. Let's do.
He also find the diameter is the or for the for the decimals, right? So
And
where it's at.
usually the size is pretty a limited window where it actually matters, because generally like the Tomo branch is really big. The way the vesicles are generated isn't super realistic. So they really clip outside that area a lot. So if you just make it too big, like, you just get these weird, like, membrane walls all over the place and it. Fine.
I was just going to put things in a membrane since why not? See, in each layer, you can add as many things as you want, just so you know. Like, we only did one in each layer last time. But now I'm just making a single layer that has 3 different things in it. So it'll, as in each iteration, it's going to randomly pick from that pool and try to place it. But these are all membrane proteins. Let's see. Oh man. I hate that. Oh, come on. Synthetic cytoplasm. Okay, you see how I have this folder called distractors? It's basically a copy of the other 4 folders. But if you open them up, every file has the word distract in it. And if you pass those PDBs to CTS, then it knows that it shouldn't make them a target, like a class target in the final ground truth. And it just puts them into the background for you. But, all right. What did I put in there? We have that and okay. Let's put a microtubule in. With assembly and okay. So now it's generating vesicular membranes. Things we've done with this, like for instance, people that I collaborated with they wanted a template of a membrane embedded protein to use as a template in template matching. And they're not easy to get technically. So we just embedded the PDB into one of these vesicles and went in and cropped it out and generated like a template that you could use to. So it has some utility outside of training neural networks, but all right. Simulate. I was just going to try to show you. What is this? Okay. So this is the model that it generated, right? It's got a bunch of microtubule pieces in it, but you can see the actual like membrane, which there's a G-coupled protein receptor like here on the inside. Is you can determine which side it flips in and out of. So that is all done in Chimera when you define where the transmembrane domain is.
I would suggest, if you want to do transmembrane, there's the OPM database. It's basically our, RCFD or membrane protein. Those files automatically work, those guys annotate their files very well.
Yeah.
If you have your own custom thing, you're fiddle around with Chimera. It works, it's not exactly great. You have to define basically where the centroid transmembrane space domain is.
Yeah, it doesn't know how to place it unless you tell it where the membrane domain is. And then based on the orientation it's saved in, it'll either go in one direction or the other. So. Oh, well. 4 minutes from our end point. Anything else, or? I know it's the last, wait, no, it's not the last day.
Well, we have a debrief in around.
Yeah. Yes.
Theoretically, could you use the segmentation you give to another model with a different one you have in Dragonfly?
I think so. For sure. I mean, there's no reason, now, they would need to have the same number of classes. Like if you have a 5-class network and a 4-class network, they just don't jive. I mean, you could erase one of the classes and force it to work. And there are ways to get around it, but yeah, I don't see why not.
So could you also like clean up like what a different software made in Dragonfly then?
I don't know. You mean like a segmentation from another?
Yeah.
Probably, if you can open it, because if you can open it as a grayscale image or something, then you should be able to extract in Dragonfly all of the regions of interest from it based on what the grayscale values are. And then you would have like something to work with there. I don't know that, I've never done it. I mean, certainly willing to try. All right. Well, thank you very much. Hopefully you can go back home and have some sense of what Dragonfly does, and maybe you can even download it and try to do something. I'll get you the tutorial. It'll help you a lot if you don't remember everything. But hopefully seeing it and seeing CTS and things like that will make it more accessible to you. And don't forget to reach out to me. We really enjoy helping people, you know, if you can, produce good results with our software. It's very satisfying for us too, so.
Could you pass along your email in the Slack?
Yes. I'm gonna stop the sharing. Yes, I'll send a Slack with links to, with my email, links to the tutorials, and in the tutorial are links to all the PDBs that we're using, even some pre-trained models. The tutorial I'm going to send you walks you through installing CTS and all of the things it needs. And yeah, just stay in touch for sure.
Okay, what else we have in store today is dinner and a reception here, but something that we forgot to do. Everyone should pin our map. So before you have dinner, you want to take a picture of everyone individually, pinning where they're coming from. Okay, so let's do that right now and then have a reception.
Where is the reception then?
I think it's gonna be here. Leave all your stuff here.